Hey guys, hope you guys are doing well. Hope your revisions go well as we get closer and closer to the exam, and hope you're having a good Easter break. So, for those that don't know me, my name is Daniel. I'm a GCSE and A-level maths tutor, and this is my YouTube channel where I just go through walkthroughs. I go through walkthroughs from different exam papers. I have an Instagram and TikTok where I make videos there as well based on just random questions. And yeah, welcome to my predicted paper one for the Edexcel A-level maths exam in June. And yeah, this predicted paper is based on a document that I made a couple of weeks ago, and there's a video on it as well. So in that video, I've just basically gone through all of the papers from 2018 to 2024, and I've categorized them into different color schemes. And then based on that prediction or based on that breakdown, I've created this predicted paper. And yeah, I'll put a link in the description to that, and I'll also put the video somewhere in the video. I think you can do that on YouTube. So if you see the video, that means I've figured it out. But yeah, that's pretty much it in terms of this predicted paper. This will be version one of two, so I'll do a paper two as well at a later point. And yeah, this paper is just basically a combination of questions that I found from exam papers that are just all online, tweaked it a bit, and a lot of them are actually my own questions as well. So I created a lot of these questions as well. Question 15, so that's definitely mine. So I'm interested to see how you guys do on that. But yeah, that's pretty much it in terms of how this paper was created. You probably would not have seen the vast majority of them, just to try and keep it a bit fresh. So it's going to be like a new paper. And yeah, what else am I going to say? Yeah, I would recommend highly that you do the paper first. So the link to the papers in the description. I'll pin it in the comments as well. And yeah, do the paper first and then come back to the video. You have 2 hours and 10 minutes to do it because I think there's 106 marks. So just a bit over 100. So I'll give you 10 minutes extra to do it. And yeah, that's pretty much it. I don't think there's anything else I need to say. But yeah, let's get into it. Okay, so question one says a circle C has center 3, 7. Given that the point P, 9 minus 2, lies on C, part A says we need to find the radius of C and find an equation for C for 3 marks. So whenever I'm doing these types of questions, or in general, I always like to try and visualize the question if I can. So we've got a circle, they've given us a couple of coordinates, right? So what I'm going to do is I'm going to get an axis going. So I'm just going to draw an axis like this, and then we're just going to use this for our question. So we've got part A. The center is 3, 7. So let's just say 3 is there. Let's say 7 is there. This is the center of the circle. And then we've got another point, 9 minus 2. Let's just say x is 9 is over there. Let's say minus 2 is down there. And then that's that point. Sorry, minus 2. So it's going to be down here, roughly. And then this is the point over there. And it lies on the circle. So what we could say technically is that the circle is going to look something like that essentially, isn't it? Let me just put it there like that roughly. What I'm going to do is I'm gonna instead of rubbing out, let me just lower it actually. So just so we've got this there, we just put this down. Okay. So we've got this 0.9 minus 2, which we know lies in it. They're asking us for the radius of the circle. Well, that's just going to be the distance between these two coordinates, isn't it? So let me just write this here. This is 3, 7. This is 9 minus 2. And I'm looking for the radius, the distance, right? So let me just draw a line to connect them. And as you can see quite clearly, just from the diagram, that's just going to be the distance between these two coordinates, isn't it? So we're just going to use the distance form to calculate them. So it's going to be the distance is going to be the square root. If you've got two coordinates, x1 and y1, x2, y2, it's going to be the difference between the two coordinates, x1 minus x2 all squared, plus y1 minus y2 all squared. Now, it doesn't matter which way they go because you're going to square them anyway. So I would just say the first pair of 3, 7 is x1, the y1s, second pair is x2, y2. So that would be, putting that in, that's going to be 3 take away 9 all squared, plus 7 minus 2 all squared, isn't it? And then that would be equal to negative 6 all squared plus 9 squared, which is the square root of 36 plus 81. What's that? 30 plus 80 is 110, 117, root 117. And let me see if that can be simplified. Probably. So let me put my calculator here. Square root of 117 is 3 root 13. So the radius of the circle is 3 root 13. So let me just label that here. 3 root 13. And that's part AI done. Now, part double I says we need to find an equation for C. So remember, this one's even easier, I think. Remember, the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared, where a and b is your center and r is your radius. And we've got each of these, don't we? So the center is 3, 7. So it's going to be, I'll put 3, 7 here. So it's going to be x take away 3 all squared plus y minus 7 all squared, like that. And the radius is 13. The radius squared is going to be 117, isn't it? So I'm just going to put 117 here. And that would be our answer for part double I. So that is done. What does part B say? Part B says we need to find the equation of the tangent to C at P, given your answer in the form of ax plus by plus c is equal to 0, where a, b, c are integers to be found. So what I'm going to do, let me just grab part B again and just put it underneath just so we have it and we can just work with it. So I don't need to keep going up and down. So that's going to be there. And what I'm going to do, I'm going to get this diagram again because it's very, very helpful when you're doing these types of questions because you can just see the problem now. So if I copy this, what are they asking us for? They are asking us for the tangent, the equation of the tangent to C at P. P is over here, isn't it? This is the point P. The tangent would be something like this, isn't it? That would be the tangent. So I'm looking for the equation of this line. How do I find the equation of a line? I need a point that passes through it, which we have 9 minus 2. And I also need the gradient, right? So what I'm going to do is I'm just going to say that the general formula is going to be y take y1 is equal to m, and then x take x1. And then now I need to figure out the x and y1, which I do have, and the gradient. So I'm going to say that the x1, y1 in this case, as we can see quite clearly from the diagram, is 9 minus 2. That is the point that passes through P, right? And I'm looking for the gradient now of this red line. Now, how do I find the gradient of this line? Remember, circle frames, even from GCSE, the radius, right, here, and the tangent are always perpendicular, aren't they? So if I could figure out the gradient of the radius, which I can do because I've got 2 points, I could figure out the gradient of this tangent here because this is at a right angle. So what I'm going to do is figure out the gradient of the radius, the blue line. So I'm just going to say, let me just move this here so you guys can see. Gradient of radius, right? Or this is the center C. I'm just going to write CP for short, right? That is going to equal y2 minus y1 over x2 minus x1, isn't it? So I'm going to do y2 and x2 going to be the P, x1 and y1 are going to be the C. It's going to be minus 2 take away minus 7 over 9 take away 3, isn't it? And that will give me minus 9 over 6. Divide top and bottom by 3, that's going to be minus 3 over 2. So the gradient of this line in blue is minus 3 over 2. Which means that the gradient of the yellow line, the negative reciprocal, because they're perpendicular, is going to be 2 over 3. So we now have the point that passes through the tangent, 9 minus 2, and we now have the gradient. So I can just use this formula on the top here. So I'll just do it here, actually. It's going to be y take away y1, which is going to be minus 2. So y minus minus 2 is going to equal the gradient, which in this case is 2/3. And then x take away x1, which is going to be take away 9. And then it's just a matter of getting into that format, isn't it, where the integers. So this is not too bad. Let me grab this and then put this here. Copy this and put this here. So let's just finish off now. This is going to be y plus 2. It's going to equal 2 over 3. And then x take away 9. I'm going to times by 3 to get rid of the fraction. That will be 3y plus 6. Remember, don't forget to times the 2 by 3. It's going to equal 2 lots of x take away 9. That means that 3y plus 6 is going to equal 2x take 18. And then getting everything, what form? ax plus by plus c, isn't it? Yeah, ax plus by plus c. So we're just going to move everything from left to right. So the x term is positive. Doesn't matter though. But anyways, everything from left to right is going to be 0 is going to equal 2x, that positive 3y will go to minus 3y. The plus 6 will go to minus 6, will be minus 18 minus 6, which means that 2x minus 3y minus 24 is going to equal 0. So A is going to equal 2, B is going to equal -3, and C is going to equal -24. And that's it. And that's question 1 finished. Okay, so question 2 says, relative to a fixed origin O, the point A has position vector 3i plus 7j plus 5k. The point B has position vector 2i plus 4j plus bk, where b is a positive integer. Part A says me to show that the magnitude of OA is the square root of 83 for 1 mark. Now remember, to find the magnitude of this position vector, it's just going to be the Pythagoras of each of the components. So I'm going to say that for part A, the magnitude of OA is just going to be equal to the square root of 3 squared plus 7 squared plus 5 squared, right? Which is going to be the square root of 9 plus 49 plus 25. 9 plus 49 is 58, plus 25, add 78, add on 5, that's going to be 83. So yeah, that's done. Perfect. You can use your calculator. Part B says, find the smallest value of B for which the magnitude of OB is greater than the magnitude of OA. Now, this is not too bad. We have the magnitude of OA, it's the square root of 83. I just need an expression for the magnitude of O to B, which I can find because I've got each of the components. Obviously, the K component is algebraic, but it's fine. So I'm going to do, firstly, the magnitude of OB, and that's going to be equal to the square root of 2 squared plus 4 squared plus B squared, isn't it? So doing that, that's going to be 4 plus 16 plus b squared, which is going to be the square root of 20 plus b squared, isn't it? Now, since they want the value of b, the smallest value of b for which the magnitude of OB is greater than the magnitude of OA, that would mean, just plugging those in, it's going to be the square root of, let me go down a bit, square root of 20 plus b squared has to be greater than the square root of 83. I need to solve for b. So square both sides to get rid of the square roots. 20 plus b squared is going to be greater than 83. Take 20 away. That will be greater than 63. Now b is an integer, isn't it? Yeah, b is a positive integer. What value of b would be more than 63? Well, if b was 7, then b squared would be 49, which doesn't work. If b was 8, b squared would be 64, which works, isn't it? So the smallest value for b squared to be more than 63, which is an integer, positive integer, has to be 8. So I'm just going to write smallest integer is 8. So therefore b is equal to 8. And that's it. And that's question 2 finished. Okay, so question 3 says, figure 1 shows a sketch of the curve of equation y is equal to 10 over the square root of 1 plus root x, where x is greater than or equal to 0. The finite region R, shown shaded in figure 1, is bounded by the curve, the line with equation x equals 4, the x-axis, and the line with equation x equals 6. Part A says, use the trapezium rule with 4 strips to find an estimate for the area of R. Show your working and give your answer correct to 2 decimal places. And this is a 4 marker. Now, what I've done is I've just summarized everything we need for part A, just down here. So remember, this one is just a standard formula question. You just need to know your formula. I can't remember if it's in the formula book or not. Somebody leave a comment in the comment section, but I can't remember. But yeah, this is your formula for the trapezium rule. Just memorize it, just learn it, and just literally apply it. So we're trying to find the integral of this here between 4 and 6, isn't it? So let me write it out. It's going to be the integral. Let me just go down a bit. It's going to be the integral between 4 and 6 of 10 over 1 plus root x dx, isn't it? Right? And the estimate of that would be, well, we need to figure out what h is. Now, h is just equal to, what you should know is actually right here, b minus a over n, where b and a are your limits and n is the number of strips. They told us that we need 4 strips. So what we can do here is say that h must be equal to 6 take away 4 over 4, because there are 4 strips. That's 2 over 4, so h is equal to 1/2, right? So I now know what h is. And then now we've got the y values. Now these are just going to be your y coordinates at your points. Now remember, because we're dealing between 4 and 6, we need to figure out each of the values between that with the increase of 0.5, right? Or a half. Let me write 0.5 as well so it's clear. So what I'm going to do is I'm going to draw a table for the x and y values of the function between 4 and 6 with this step increase of 0.5. So I'm going to have x here, I'm going to have y here. And I know it goes from 4 all the way up to 6 with 0.5 as a step. So it'll be 4 and then 4.5, 5, 5.5, and then 6. So the y values in this formula here are going to correspond to the y coordinates of our function at each point. So the function is 10 over 1 plus root x. I'm going to figure out what y is at each point. So my calculator is here. And then what I'll do, let me just zoom out a bit so I can put this here as well. So I'll put this here, and I think that should be okay. So now, formula is 10 over 1 plus root x. So when x is 4, that's just going to be square root of 4 is 2. That's going to be 10 thirds, isn't it? So that will go there. That'll be 10 thirds. And then I'm going to do it for each of these now. 4.5 is going to be that there. I'm going to press SD. I'm going to just approximate this to about 6 decimal places. As long as you do it to a good amount of decimal places, you'll be okay. Just because I'm going to run out of room, I'm going to put it there. It's going to be 3.20. What was it again? 377. 377. And then I'll just do it to 2. That should be fine. Yeah. And then I'm going to do it for 5 now. So I'm going to change that to a 5. That's going to be that number there, which is going to be, I'll do it here, 3.090. And then that will be 1699. 1699. It's fine. That's that one. What is 5.5 equal to? Change that to a 0.5. That's going to be that number there, and that's going to be 2.989. 3508. And then the last one is going to be, change that to a 6. Minus 2 plus 2 root 6. You know what? I'll leave it like that because that's not too bad. Minus 2 plus 2 root 6. And then now what I'm going to do is just literally punch all of these values into the formula here. So let me grab this formula again. And then we're just going to literally punch everything in. So putting that in, that's going to be, you know what? Just because you're in an exam, I will just write it out. So it's going to be 1/2. Remember, h was also a half. It was 0.5. That's h. Y0 is your first y coordinate, which is going to be 10 thirds in this case. 10 over 3. Plus, and then it's going to be 2 lots of all of the middle terms, which are going to be these 3. And then that will be 3.203772 plus 3.0901699 plus 2.9893508, like that, and then plus yn, which is the last term, which is that third, minus 2 plus 2 root 6. And then all you're going to do now is just punch this all into your calculator, and then that will give you your answer. So what I'll do, let me just make this a bit smaller, just so you guys can see it when I plug it in. Let me just make this a tad bit smaller so it goes there, and I think that's okay, to be honest. Bring it up. Yeah, and I think you guys will be able to see that fine now. Yeah. So I'm going to plug everything in. So that would be 1/2 times another half, like that. And then I'm going to plug in everything. That would be 10 thirds. 10 over 3, that was y0. Plus 2 lots of all of the middle terms. So it's going to be 3.203772 plus 3.0901699 plus 2 points, that's 9, isn't it? 9893508, like that. And then close bracket, and then the last term, which is yn, is going to be that third. So minus 2 plus 2 root 6. And then I'm going to close that bracket, and I'm going to close it again. So that is going to be my answer there. I'm going to click equals. I get that number there, which is equal to 6.1997, blah, blah, blah. What degree of accuracy did they want it to? Let's check. They said to 2 decimal places. So to 2 decimal places, that's just going to be 6.2, isn't it? Sorry. Approximation signs wrong at that. That's going to be 6.2. And that is your answer to part A. And that's that. Okay, so question B says, using your answer to part A and making your method clear, estimate the value of these two integrals here. So the first one, I, is integral between 2 and 3 of 60 over 1 plus root 2x. And the second one is between 4 and 6 of 13 plus 3 root x over 1 plus root x. Now, I really like this question because it requires a little bit of intuition and thinking outside the box. And it doesn't come up a lot. I like to categorize this question as estimating further integrals, and I put it as a yellow topic in my topic breakdown PDF. And the reason why is because it's only come up twice. It came up in paper 2 of 2020, question 1, and it came up in 2022, question 5 of paper 2 as well. So it's only come up twice. And the reason this question is nice is it requires you to basically use algebra to start off with something that you know as a fact, and basically just use algebra to get what they've given you, essentially. So remember, in part A, we figured out an estimate for the integral of this function here between 4 and 6. And we remember the answer was 6.2. So what I'm going to do is I'm going to just write what we figured out in part A. The integral between 4 and 6 of our function, 10 over 1 plus root x dx, right? This is equal to 6.2. Now, we basically want to use this as a reference and use algebra to get what they've got given us in the questions. So if I look at part I, right, 60 over 1 plus root 2x, there's a little bit of differences here. Now, firstly, I can see that the numerator is a 60, and in the denominator, the square root is a 2x now instead of just an x. So what I'm going to do, I'm going to do a couple of things here. Now, what I'm going to do is I'm going to call our original function, I'm going to call it f of x. So it's going to be 10 over 1 plus root x. Now, firstly, what I notice is that the denominator in our part I has a 2 there. So if I just forget about the 60 for now and just look at that, then, well, it would be 10 over 1 plus root 2x. Now, what would that be in terms of f? Well, remember, whatever goes here must go here. If this is now a 2x, this is going to be f of 2x. And now you need to think to yourself, well, what happens? What is this? This is a graph transformation. The function inside has a 2 now. This is just going to be a horizontal stretch, right? It's going to go in by a half. Remember your graph transformations, right? It does the opposite when it's inside. So because it's times in by 2, it's going to half. Now, what implications does that have? Remember what we did in part A, right? Essentially, we had a graph, right? We've estimated the area between 4 and 6, and it was 6.2, right? If this is now shrunk by a half, it's gone in by a half, right? Then what will happen is that the area will now be half as big, isn't it? Right? Because now this is going to be a 2, that's going to be a 3, right? So this has just been half. So this is going to be 3.1. So what we can say for sure is that the integral between 2 and 3 of 10 over 1 plus root 2x dx, this is definitely going to be 3.1 because it's just half of the area that we found out in part A. Now, remember, this isn't the question for part A, though, for I. They had a 60 there. So let me just grab that so we can use it as a reference. So let me just put that there. So we know that this is true. This is 3.1. What is the difference between this one on top and that one underneath? Well, the only difference is that the numerator is 6 times as big. So we're just going to times that by 6, aren't we? Which means that we're going to times the area by 6. 3.1 times 6 is just going to be 18.6. So the answer to the first part of B is 18.6. And you can see it's a bit tricky. You've got to think outside the box a bit, but that is the answer for the first part. Now, the second one, let's have a look here. This one's a bit trickier. They're both tricky, to be fair, but this one I think requires a bit more thinking outside the box. Now, remember what I said when you're doing these types of questions, when you're estimating further integrals, is you want to use this as a reference. Now, if I just stare at these, let me just stare at these here. So the integral in blue is what we know as fact, right? If I look at what I've got here, which is what I'm trying to calculate, let me just make this a bit bigger. What I want to do is somehow create this. I want to bring this to life because this is what I know. I know this is 6.2 and the limits are the same here as well. So if I can somehow bring that to life, I'll be good. Now, How can I do that? Well, I've got the 1 plus root x on the denominator. That's absolutely fine. But the numerator, there's a lot going on here. But I know I needed 10. Now, since I needed 10, which is here, and I've got 13, it's a bit weird, right? But what I would do, right, is say, well, 13 to rewrite as anything I like. What I'm going to do is I'm going to rewrite it as 10 plus 3, right? Because 13 is the same as 10 plus 3. I'm allowed to do that, right? 10 plus 3 is 13. I can replace it. And then I'm going to put 3 root x here. And then this is going to be all over. Let me just break a nicer line. This is going to be all over 1 plus root x, isn't it? And this is the integral between 4 and 6 dx. Now, we've got this here. We've got the 10. Why is this helpful? Because, remember, if I put this in green here, this here I can isolate just by separating the fractions, can't I? Because I can put that there, and then I could put this under the same denominator. So what I'm going to do is I'm going to split this now. I'm going to say that the integral between 4 and 6 will be the same as 10 over 1 plus root x, right? Plus 3 plus 3 root x over 1 plus root x, can't we? Right? These are the exact same thing. Now, why is this helpful? Remember, we're integrating two separate terms. You can just separate them, can't you? So the actual question now is just the integral between 4 and 6 of this one, 10 plus root x dx, plus the same thing now, 4 to 6 of 3 plus 3 root x over 1 plus root x dx. Now, this one here, right, on the left-hand side is exactly what we have here, isn't it? It's 6.2. We know this, right? So I'm going to put 6.2 here. Now, how do I integrate that? Well, this is just requires a little bit of algebra. If you look closely, the numerator is just 3 times the denominator. Because what I'm going to do, if I just take out a 3, I'm going to have 1 plus root x, and it's going to be over 1 plus root x, isn't it? Like that. Those will cancel. I'm left with 3. So this here is just actually asking me to integrate between 4 and 6 of 3 dx. So what is that equal to? This is very, very easy. Now integrating 3 becomes 3x between 4 and 6. Plugging that in, that's going to be 3 times 6 minus 3 times 4, like that. 18, take away 12, right? Which is 6. So we now know what this is equal to. This right here was 6.2. This right here is 6, right? So the answer is just going to be 6.2 plus 6, which is just going to be 12.2. And that is the answer to part double I. Let me just zoom out so we can see all the work. And a bit tricky, but yeah, that's pretty much it. And we're done. Okay, so question 4 says express the limit as delta x tends to 0 of the sum between 1 and 4 of e to the 3x delta x as an integral for 1 mark. Now, this is super easy. Make sure you know this. It's the integration of the limit of a sum. I've even written it for you guys. I shouldn't have actually, but this is just going to be the integral between 1 and 4. It's a definite integral between the function, I should say, of e to the 3x dx. And that is literally it. That's why it's only 1 mark. So make sure you get this if this comes up in an exam. Part B, it says, hence show that the limit as delta x tends to 0 of the sum between 1 and 4 of e to the 3x is equal to e to the k times by e to the 3k minus 1 over k, where k is a constant to be found. So we just essentially need to integrate our part A and then just use algebra to get into that form, isn't it? So that's not too bad. So part B, it's the integral between 1 and 4 of e to the 3x dx, and I need to get it into this form here. So what I'll do is whenever I'm doing show that, so always have the show that as a reference so I know where I need to go. So let me just put it here and then paste this over here. So firstly, integrating that. How do we integrate exponentials? Is very, very simple. Because we're integrating, we're going to differentiate the power, which is going to be a 3, but we're going to divide by it, the reverse chain rule essentially. So it's going to be 1 over 3, and then we're going to times by the original function e to the 3x. And that will be the integral, and we're integrating this between the limits of 1 and 4. So now evaluating this now is going to be 1/3, and it's going to be e to the 3 lots of 4 minus 1/3, and then e to the 3 lots of 1, like that. And then I just need to get it into that form, don't I? So it's going to be a third e to the 12 minus a third and then e to the 3, isn't it? Now, to show that it's all over, so I'm going to take up the third and I can put it all over 3, isn't it? So I'll just do like this. E to the 12 take e to the 3. And then obviously I can put this all over 3. And that will be e to the 12 minus e to the 3. And just to show that again, we need to take out a factor of e to the something. So if I look at the numerator, that's easy. We can take out a factor of e to the 3, can't we? So if I just put that there, if I factor out e to the 3, it will be e to the 3, and then it will be e to the, what would that be? I'm taking it out, it's going to be a 9, isn't it? Because we have to add the powers, minus e to the, no, not e, it should be 1, isn't it? Because I can take that out like that, and this is all over 3. Comparing that now, k is going to be 3, isn't it? Because 9 is 3 lots of 3, so it's going to be e to the 3, and then e to the 3 lots of 3, because 3 3s are 9, right? Minus 1 over 3. So if I compare that now, we can see quite clearly k must be equal to 3. And that's it. Okay, so question 5 says, the curve C has equation y equals g of x, where x is the element of the reals. Given that g dash of x is equal to 3x plus a half cos x, the curve has a stationary point with x coordinate beta. Beta is small. Part A says we need to use the small angle approximation for cos x to estimate the value of beta to 3 decimal places for 3 marks. So, small angle approximations, they've asked us for the approximation for cos x. So that's the first thing I would do, is write that out. When x is small, cos x is approximately equal to 1 minus x squared over 2, isn't it? So, we want to figure out what beta is, and beta is the x coordinate of the stationary point. Now, remember, stationary point's a key phrase. Whenever you see stationary point, minimum point, turning point, and there's another one, stationary point, minimum point, turning point, maximum point, minimum, maximum. These are all synonyms for dy dx equaling 0. In this case, we're dealing with function notation, so it's g dash of x. So the stationary point is going to be where the gradient function is 0, and luckily they've given that to us. G dash of x is equal to 3x plus a half cos x. So for part A, I'm going to set that equal to 0. So I'm going to say 3x plus a half cos x must be equal to 0 at the stationary point. Now, the value of x is beta, and we know that beta is small, so we can actually use our small angle approximation here, can't we? So what I'm going to do is I'm going to say 3x plus a half. Now remember, cos x is approximately a half, 1 minus a x squared over 2. So I can put that there, and then this must equal 0, isn't it? Right? So all I need to do is just work out what x is. So I'm going to expand the brackets first. 3x plus a half minus a quarter x squared is equal to 0 times by 4 to get rid of all of the denominators. That will be 12x. That would be 2 plus 2 minus x squared is equal to 0. And then I'm going to put this on the other side. So it's going to be x squared minus 12x minus 2 is equal to 0, isn't it? And then now I need to figure out what x is, which is going to be beta. So I'm just going to solve this using my quadratic solver. So I put this here. It will be, where is it? Equation, polynomial, 2 will be 1 minus 12. It'll be minus 2. So I get x, which is beta, 6 plus root 38, and the other one's going to be minus, isn't it? Obviously. So yeah, we get plus or minus. Now remember, x is equal to beta, isn't it? Because beta is the value of the stationary point, which is what we're solving. So beta, essentially, is equal to either this one or that one. Now remember, they said find the value of beta, didn't they? Singular, not plural, right? So there's only one value. So which one do we pick? Well, remember, they did also tell us that beta is small. So we just need to check both of them. So if I press SD, we get that one there. Beta is equal to minus 0.1. They want it to 3dp, which is going to be 164. Or beta is going to equal the other one, which would be x1 is going to be 12.164. right? So you're just going to say as beta is small, yeah, you're going to say beta must be equal to the first one, right? Because it's closest to 0, very close to 0, as opposed to 12. So that would be part A. Part B, which is only 2 marks, says that the point Q, 0, 2 lies on C. Find the equation of the tangent to the curve at Q, given your answer in the form of y equals mx plus c, where m and c are constants to be found. So again, this is not too bad. They're asking you for the equation of a tangent. A tangent is a line, so they're asking you for the equation of a line. So you could either use y equals mx plus c or y minus y1. I just use y minus y1 because that's what you normally use in A level anyway. But either way, it doesn't matter. Y minus y1 is going to equal mx minus x1, right? So we need a point. Our x1 and y1 is going to be 0, 2. We need the gradient now. The tangent gradient is just going to be the value of the gradient function at that point, right? Now x is 0. What was the gradient function again? It was that, wasn't it? 3x plus a half cos x, isn't it? But let me just grab this here just so it's super clear. So it's going to be here, and then I'm just going to plug in x equals 0, isn't it, to give me the gradient to give me the gradient of the tangent. So g dash of 0 is going to be 3 lots of 0 plus 1/2 times the cosine of 0, and that is just 0. That's 0 there. The cos of 0 is 1. This is a half, right? So the gradient is 1/2. So therefore, the answer is going to be y take away 2 is going to equal m, which is a half, x minus 0. And we need it in the form of y equals mx plus c. So I'm just going to do all of that there. It's fine. Y minus 2. So y minus 2 is going to equal 1/2 x, isn't it? Because that will just be 0. And then I'm just going to say y is equal to 1/2 x plus 2. To be fair, it's probably quicker if we do y equals mx plus c, but it doesn't matter. And yeah, that's it. Finished. Okay, so question 6 says a curve C has equation y equals f of x. Given that f dash of x is equal to ax squared plus bx minus 15, where b is a constant, the y-intercept of the curve C is minus 20. X minus 3 is a factor of f of x. Find in simplest form f of x for 6 marks. Okay, so firstly, what is the question asking you for? It's asking you for f of x. The first bullet point gives you f dash of x, which is the gradient function. How do you go from the gradient function to the original function? You integrate, don't you? So what I'm going to do is say that f of x, right, would be found by integrating the gradient function, wouldn't it? With respect to x, obviously. So I'm just going to integrate that. So it's going to be the integral of 8x squared plus bx minus 15 dx. And now this is just standard integration. So we add 1 to the power, divide by the new power. So that will go to a 3. And I would divide by 3. But we were already times it by 8, wasn't we? So we can just combine the 8 and the division of 3 to make 8/3. So I'll write 8 over 3 instead. So that becomes 8/3 x cubed. Plus, and then we add 1 to the power x squared, divide by the new power. There was already a b there. I'm going to combine the b and the division of 2 to be b over 2. So I get that there. And then when we integrate a constant, we just times by the variable that we're integrating with. So it'll be minus 15x. And do not forget your constant of integration. So this is going to be f of x. Now, this is where we're at. We're trying to figure out what f of x is. So we need to figure out what the constant c is and the constant b. What does the second bullet point say? The second bullet point says that the y-intercept of c is minus 20. So immediately we can just recognize that this constant c here has to be minus 20, doesn't it? Or if you didn't, you can just plug in x equals 0, make the y equal 20 minus 20, and you get the same thing. So what I'm going to do is I'm going to just say c is equal to minus 20, right, from second bullet point. Second bullet point. And now that means I can update my equation. So I'm going to say now that f of x will equal a over 3 x cubed plus b over 2 x squared minus 15x minus 20. Now we're trying to figure out what f of x is. What's left to do is figure out what the constant b is. And then now you just look at the last bullet point. X minus 3 is a factor of f of x. This is just a factor theorem, isn't it? When you plug in x equals 3, your function will be 0, right? So I'm just going to say x minus 3 is a factor, So from the factor theorem, theorem, right? Then that would mean that f of 3 would equal 0. So we're going to plug in 3 into our function, make it equal to 0, and that will give us what b is. So doing that would be f of 3, or you know what I'll do, let me just do this actually. This is f of 3. I'll plug it in just so it's super clear. A over 3, 3 cubed, plus b over 2, 3 squared minus 15, and then 3 there minus 20, and f of 3 is equal to 0, isn't it? So I'll put that there, and now it's just a matter of tidying that up. So 8 over 3 times 3, that's 8 times 3 squared, which is 8 times 9, that's 72, isn't it? Let me just double check. 3 cubed over 3 is 3 squared. 3 squared is 9, 8 times 9, 72, that's fine. Plus 9 over 2b minus 45 minus 20 is equal to 0. So what is that going to be? That means that's 9 over 2b, right, is going to equal these two going on that side, which is going to be, that's minus 65. That'll be a plus 65 there. And then I'll take away that 72, isn't it? So, yeah, that's fine. So that means 9 over 2b is going to equal, that would be minus 7, isn't it? And then that would be times by 2, 9b is going to equal minus 14. So it's going to be minus 14 over 9, isn't it? Minus 14 over 9. So we now know what b is, and now we finished the question. So I'll just put it here, actually. I'll put it on the side here. That means that our original function, f of x, right? This will equal a over 3 x cubed plus, now b is minus 14 over 9, isn't it? Right? So it's going to be minus 14 over 9. Minus 14 over 9, that's b. And it was over 2, like that. And then it's going to be x squared, like that. And then it was minus 15x minus 20. And then now it's just about tidying that up, isn't it? So that would be, I'll do it here. That would be minus 14 over 18, isn't it? Divide top and bottom by 2. That would be 7 over 9. So the final answer is going to be f of x is going to equal, get here. Final answer is going to be f of x is going to equal a over 3 x cubed minus 7 over 9 x squared minus 15x minus 20. And that's it. And that will give you the full 6 marks. Okay, so question 7 says, find the first 4 terms of the binomial expansion in ascending powers of x of 1/4 minus a half x to the minus 3 over 2, where x ranges between minus a half and a half, given each term in its simplest form for 5 marks. Okay, so standard binomial expansion question, the year 13 type. So remember the formula for it. Let me just write it here. So the general formula will be, if I've got 1 plus ax all to the power of n, then this will equal 1 plus n ax plus n minus 1 over 2 factorial ax squared plus n minus 1 and then n minus 2 over 3 factorial and then ax cubed and so on and so forth. So how many terms did they ask us for? The first 4 terms. So we need to go up to the third power. So if we look at what we've got though, we've got to be careful here, because if you look at the expression, there is a quarter where the 1 should be. Now, when that's the case, you've got to just manipulate it algebraically to get the 1 so that you're able to apply the formula above. So how do we do that here? What you're going to do is you're going to just factorize, right? So if I want to get a 1 there, I can take out a quarter, can't I? If I take out a quarter like that, there would be a 1 there. And then, well, what do I times a quarter by to get me to a half? It would be 2, isn't it, right? 2 quarters are 1/2. So I'd put a minus 2 there, and it'll be like that. And it'll be all to the power of minus 3 over 2. Now, remember your index laws. If I have AB all to the power of n, then this is just a to the n times b to the n. So that means I can rewrite this as 1/4 to the minus 3 over 2. And then that would be multiplied by 1 minus 2x to the minus 3 over 2. And then now all you need to do is just evaluate that. So let me just put this into my calculator. I think it's going to be 8 though, but let me just put it in. 1/4 to the power of -3/2 is going to be, let's see what it is. Yes, 8. So you've got an 8 there, which means now once you do the expansion with this, you're going to multiply every single term by 8. So don't forget that 8, right? But now we're just going to work with this expansion now. And let's just get that formula again. And then we'll just literally apply it. It's very, very straightforward, I believe. But yeah, so let's do that here. I'm going to copy this and bring this here. And then now all I'm going to do is just literally identify what our A is, what our N is, and we're literally done, to be honest. So in our case, we can see that our A in this one above here is going to be -2, and our N is -3/2. So all we're going to do now is just plug this into the formula. And don't forget, we need to times by 8 at the end. Yeah, so let's do that. It's going to be equal to, so let me write here actually, so it's super clear. 1 minus 2x to the -3/2. If I use that formula, it's going to be 1 plus -3/2. And then ax, which in this case is going to be -2x, isn't it? Like that. And then plus n, which is -3/2. Like that. Times by n minus 1. If I take 1 away from -3/2, that's going to be -5/2. Like that. All over 2 factorial. And then that would be -2x all squared. And then plus the next term, which is going to be n, which is -3/2, n minus 1, which is -5/2, n minus 2, which is going to be -7/2, and it's going to be all over 3 factorial, and then that would be -2x all cubed. And now it's just a matter of just simplifying this. So we'll do the first one. I'll do it here. It's going to be, let me just put this here. Okay, that's okay. So it's going to be 1. The 2's are going to cancel, right? Minus minus will cancel. That's going to be 1 plus 3x. And then with these ones, what I like to do, honestly, I would just put this all into my calculator. So I'll do that just so we can see what we get. So putting that into my calculator, the fraction is going to be, I'll put it here, it'll be -3/2, -3/2 times by -5/2. You can do it without a calculator, to be honest, but why would you when you've got a calculator? So you can just be safe. 2 factorial there. Where's the factorial button? I know it's 2, but I'm just looking for it again. Where's the factorial button? Oh, there it is. Yeah. So we get that there. And then that is 15/8. So that would be, the next will be 15/8. And then obviously -2x all squared would be a positive 4x squared, isn't it? 4x all squared. So it'll be like that. Like that. So I've just expanded this one. This is positive 4x squared. And then the next term we're going to do is going to be this one here. So it's going to be, we're going to times by the 7/2 now, aren't we? The -7/2. -7/2. Like that. And then we're going to change it to 3 factorial now. Like that. And that is -35/16. Right? So I'll remove this for now. It's going to end up being positive anyway, but we'll see. -35/16, right? And then now we're going to times by that. -2x all cubed is going to be -8x cubed, isn't it? So we get that there. Now remember, this is the expansion for this. We have to times by 8 at the end, so I haven't forgotten that. Let's just tidy this up here. So it'll be equal to 1 plus 3x. And then what would that be? That would be 4/8 is 1/2. That's going to be 15/2. X squared, like that. And then this one is going to be 8/16, which is also a half. It'll be positive. The two negatives make a positive. 8/16 is a half. It'll be 35/2 x cubed. Now remember, this is the expansion for 1 minus 2x to the -3/2. That wasn't our question. Remember, there was an 8 here. There was this one at the front. So when we've done all of that, which is what we've done now, we've done everything in yellow. We've expanded this. We just need to times it by the number in green, which is actually 8. So the final answer is just going to be, let me just write final answer here. It's going to be equal to 8 lots of all of that. So I'll do that there. Let me just copy this and bring this there. Put that inside. Let me move this bracket to the right. So we're just going to times everything by 8. So what would that be? That would be 8 plus 24x plus 8 over 2 is 4. 15 times 4 is 60. 60x squared. And then plus 8 over 2 is 4 again. 35 times 4 is 70, 140. So 140x cubed. And that would be your final answer for part A. And that's it. Okay, so part B says, given that 1/4 minus a half x to the n times a quarter minus a half x to the minus 3 over 2 is equal to a quarter minus a half x to the half. Part B says we need to write down the value of n for 1 mark. Right, so first thing that I noticed is that the bases are the exact same, aren't they? They're the exact same thing. So instead of writing them all out again, I'm just going to say equal to y, for example, right? So if I do that there, do that there, do that there, then that would mean for part B, all right, here, it will be y to the n times by y to the minus 3 over 2 is going to equal y to the a half, right? Just write, setting it equal to y just makes it easier to work with. You don't need to keep writing it out again. Now, they all have the same base, so we can just apply our index laws. So we can add the powers together, which would mean that we have y to the power of n. N plus minus 3 over 2 is going to be n minus 3 over 2. And then that will equal y to the half. Now, the bases are the same, which means that we can equate the powers, doesn't it? So we can just say then that n minus 3 over 2 must be equal to a half. And so if I add on the three halves now, it'll be a half plus 3 over 2, which is equal to 4 over 2. So therefore, n is just equal to 2. And that is it. And that's why it's only one mark. So that's part B done. Part C says, hence or otherwise, find the first 3 terms of the binomial expansion in ascending powers of x of 1/4 minus a half x to the half, right? Now, it says hence because this is what we're dealing with here. And we've shown that it's equal to that with a power of n, which is 2, times that. And if you notice, this is the exact same expansion we did in part A, isn't it? Right? So that's just something to make a note of, right? So let's actually get what we did in part A, which was that one there. This was our answer. So let me grab it. And I'm going to say, I'm going to copy this here. And I know that 1/4 minus a half x to the minus 3 over 2 is equal to that, right? Up until the fourth term, right? Now, we're looking for this one where it's a half. And we know in part B, that is the same as doing it to a power of 2 times that minus 3 over 2. So what we can say here is, let me just grab this here. So the question is asking us to work out what this is. 1/4 minus a half x to the power of a half. And we know from part B that this is equal to 1/4 minus a half x to the power of 2, because n was 2, multiplied by 1/4 minus a half x to the power of minus 3 over 2. And we've got this expression here. This one is the answer to part A. And in this one, because it's a power of 2, you can just expand, can't you? So doing that, what would we get then? Well, what I'll do is I'll do this one first. If I expand that bracket, you can do it by doing 2 brackets on the formula, but I'll just do it like this. You know what? Because it's I'll do it so it's super clear actually. So I'll write out twice and then expand it and then see what we get for it. Like that. And then like that. That is going to be 1/16. This one is going to be minus an eighth x. This one is going to be the same thing, minus an eighth x. And then this one is going to be plus, it's going to be a quarter x squared, isn't it? And then tidying that up a little bit more, 1/16. We've got 2/8 here, minus is going to be minus 2/8, which is just a quarter. So minus a quarter there, x, and it'll be plus a quarter x squared. So this bracket is done, isn't it? This one here is done. We've done this one, right? It's that one over there underneath. So what we need to do now is just multiply it by the binomial expansion we did in part A, which is this one over here. So what I'm going to do is I'm going to say then that it's just going to equal, I'm going to copy this here. I'll put in a bracket as well. Copy that one there. So this is the first part. And I put in a bracket now. And we would multiply by the binomial expansion of this one, which we did in part A, which is this one right here. So I'll copy this and put this here. So that would be over here. So paste that there. Perfect. So what I need to do is work out what this is, and the question asks us to do it up until the first three terms. So I'm going to go up until the x squared term, aren't I? So how do I go about doing that? It's just a matter of just expanding now. So it would be that one and that one, right? Then it would be, I'm going up to the square term. So that one and that one there. And then I'll stop here for that one. And then, you know what I'll do? I'll just do it bit by bit. So I'll just do these now. It's going to be 1/16 times 8 is going to be 8/16. That's going to be a half. That's going to be the first one. 1/16 times 8. And then the next one's going to be a 16th times 24. What I'll do is I'll just get my calculator. So I'll just do it quickly. So it's going to be 24 over 16, which is going to be 3 over 2. So the next one's going to be plus 3 over 2x. And then this one is going to be 60 over 16. 60 over 16. And that is 15 over 4. So that'll be 15 over 4x squared so far, like that. And because I'm going up until the third term, which is the x squared power, I'm going to stop with the 1/16. Now I'm going to do these ones. So I'm going to do this one here, like that. And I'm going to do this one, like that. So minus a quarter x times 8, that's 8 over 4. It's going to be minus 2x. And then the next one is going to be minus a quarter times 24. 24 over 4 is 6, isn't it? So it's going to be minus 6x squared, isn't it? Because there's an x there, an x there. And because I'm going up into the squared term, I'm going to stop there, aren't I? And then now, the quarter x squared, I'm going to times with the 8. And that is it. I'm not going to go any further because I'm going up until the squared term. I don't want any higher powers. So it's going to be a quarter times by 8, which is obviously 2. So it's going to be plus 2x squared, like that. And then now we're here. It's just a matter of just simplifying now. So in terms of the constants, there's only a half. That's fine. I've got to do 3 over 2 take away 2, isn't it? And that's it. I'll just do it on my calculator. 3 over 2 take away 2. That is minus a half. So minus a half x. And then I'm going to do 15 quarters take away 6 plus 2 to get the coefficient for x. 15 quarters. 15 quarters take away 6 plus 2. That gives me minus a quarter x squared. And that will be our final answer for the first few terms of the expansion of 1/4 minus a half x to the half, right? It's equal to 1/2 minus a half x minus a quarter x squared. And that's it. Okay, so question 8 says the continuous function f is defined by f of x is equal to 9 plus 3x when x is less than or equal to 6, or b minus ax squared where x is greater than 6, where a and b are positive constants. A sketch of y equals f of x is shown in figure 2. Part A is to find the range of f for 1 mark. So what do we have here? We've got a piecewise function, right? Function which is comprised of two separate functions joined together. It's continuous, so there's no bogey spots or anything like that. Part A says we need to find the range. Now, whenever you're finding the range of a function, remember it's the set of y values that your function can take. So I always like to think of it as a picture. You're looking at a diagram, right? The y values is where you go up or down. So if you look at your picture, what is the highest value that this graph could take? What is the lowest value it can take? So what I'm going to do, I'm just going to zoom in a bit, so it's just easier to look at. So if we look at the graph, quite clearly we can see that there's going to be a maximum point over here, right? And that is where the two graphs intersect each other, isn't it? So we just need to figure out what that value of y is here. And because it's continuous, it's just going to go down forever, isn't it? So it's just going to go down to infinity. So it's going to be, we can just say, I'll just write here the range, right? Let's just say this point is called, I don't know, okay? The range is going to be f of x is going to be less than or equal to whatever that value of k is, isn't it? So we need to figure out what that y value is. And we know that they intersect at x equals 6, isn't it? Because that's 6 is the point where they go into their different functions. So we know we need to just plug in 6 into one of these to figure out what that is. Now we have the linear function on the left, right? We don't know the quadratic one, so we can't use 6 to determine what it is for now. So I'm going to plug in x equals 6 into my linear function, and that will give me the value of k. So I'll just do that here. I'll just put part A on the side here. Part A is going to be, I'm going to do 9 plus 3 lots of 6, which is equal to 9 plus 18, which is 27, isn't it? So therefore that value of K, which I stated is 27, and the range, right? Remember the range you have to write like this, is going to be f of x is less than or equal to 27. And that is absolutely fine. So let me just zoom in a bit more, and then I'll change that K to a 27. Perfect. Right? And it just goes down forever. So the range is going to be 27 or anything less than that. So that's fine. That's done. Okay, now part B. Part B says, given that one of the solutions of the equation f of x equals 0 is 12, part B says find the other solution and find the value of A and the value of B for 4 marks. Okay, so what I'm going to do is I'm going to grab this diagram again, right? Because this is what we're going to be using. So I'm going to grab that diagram. I'm going to put this here. I'll put this here, and I'm going to get the question again as well, because that's what we're going to need. So just copy that as well. Okay. Now, what did they tell us? They told us that one of the solutions of the equation of f of x equals 0 is 12, right? F of x equals 0 is where the graph intersects the x-axis, which are the roots, right? So they're saying that one of the roots is 12, right? So what we're saying here is that x is equal to 12 when x is equal to 12 when f of x is equal to 0, or y. So I'm gonna plug in x is 12 into my diagram. Now x is 6 is there. That tells me that this root that they're describing here must come from the quadratic curve, isn't it? Right? So I'm going to put 12 there. And then the other one is going to be over here, which is the linear one. So we need to find the other solution. Since we've identified that the root at 12 is for the quadratic function, then that means I just need to set the linear function equal to 0 to figure out what the other root is, isn't it? So let me get my two functions again, actually, because I should have got that as well. Let me just grab that and then grab these as well. And then I think that's pretty much it. And then we're done. Okay, so let us do that and see what we get. So if I plug in, if I set the linear function equal to 0, that will give me the other root, isn't it? Right? Remember, this is the graph of y equals 9 plus 3x. I'm going to set equal to 0 to figure out what the root is. So I'll do that here. So I'm going to say 9 plus 3x is equal to 0. That means that 3x is equal to negative 9, which means that x is equal to negative 3. So the other root is negative 3, and I will mark that on the diagram. Why not? So that's going to be minus 3. So that is BI done. The next part says we need to find the value of A and the value of B, right? So we need to complete the quadratic equation, the quadratic function. Now, whenever you're trying to find constants of an incomplete function, right? It's always the same thing each time. You need coordinates that pass through that point, so then you can plug it in and then figure out what the values are. Now, if I look at the diagram again, remember, it's just a visual diagram we're looking at. We're trying to figure out what this quadratic function is. Now, do we know any points that are on this graph? Well, we do. We've got this one here. This coordinate here is when x equals 12, y is equal to 0. And we've also got the point at the top, remember, because that's where they both intersect. And that is when x equals 6 and y is equal to 27. So I'm going to use these two coordinates, which I know pass through this yellow quadratic curve, to figure out what A and B are. So let me get the curve again. So I'll write y for now. I'm just going to write y just because it's easier to write. B minus ax squared. And I know 2 points that pass through this, don't I? So I know the first point was when x equals 12, y was equal to 0. And the other point was when x was equal to 6, y was equal to 27, the maximum value of this function. And I can plug these into both. I can plug both of these coordinates inside to figure out what A and B are. So I'll do the first one. So y is 0 there. I'm going to have b minus, and then I'm going to have a, and then I'm going to have 12 squared. That is just 0 is equal to b take away 144a. So therefore, I'm going to have 144a is equal to b, isn't it? So that's fine. That is one equation. And then the second equation I can do by plugging in the other one. So I'm going to do it here. That would be when y is 27, I'm going to have 27. That will equal b minus a, and then 6 all squared, isn't it? Like that. And then that is 27 is equal to b minus 36a. And that means that 36a, right, if I move that onto that side, is going to be equal to b take away 27. like that. And that would be equation 2. So I've got a simultaneous equation which I can solve to figure out what A and B must be. So what will we do? Might as well just use substitution. I'm going to plug equation 1 into equation 2. So I know that B is 144A from equation 1. So if I do that there, that tells me that 36A, looking at equation 2 now, I'm going to sub in what B is equal to in equation 1, which is 144A, right? And then minus 27. And then that will allow me to figure out what A is. So if I do that there, 27 would go there. What is 144? Take away 36. That's going to be 108, isn't it? Yep. So put that there. So I'm going to have 108A is going to equal 27, which means that 27 over 108 must equal A. So what is that? That is 4, no? 27 goes into 108 4 times. That's a quarter, sorry. A is a quarter, isn't it? Yep. 27, yeah, 100%. A is a quarter. So now I know what A is. I can plug this into B or into equation 1. So equation 1, we know that 144 A is equal to B. And now I know that A is a quarter, so it's going to be 144 divided by 4 is equal to B. And that is I can't think. 144, 50, 25, 22, 11, 36. Mate, that took way too long. B is equal to 36. So therefore A is equal to a quarter and B is equal to 36. Let me just double check that because that will be embarrassing. 36 times 4 is 144. Perfect. All right. So we've done that. We've got A and B. Let me just write that so it's clear. So A is equal to 1/4 and B is equal to 36. Perfect. All right. So now we've done that. Now the last part, there was one more part to this question, wasn't there? Yeah, it was right here. We need to find the value of f of 0. So, and it's only 2 marks, so it's probably not that bad. Let's do this one. Now, what was the function again? Let's get the function because that's what it's defined for. And we also know what A and B are, so I might as well put that in there. What else are we gonna do? Okay, so we know that this is now gonna be 9 plus 3x at the top. X is greater than or equal, less than or equal to 6, sorry. And B was 36, wasn't it? Yeah. B was 36 and A is a quarter. So we get that there and then like that, and that's for X is greater than 6. And this is a function. This is f of X, isn't it? Okay, and we want f of 0. So firstly, it's a composite function. We need to figure out what f of 0 is equal to first. Once we figure out what that's equal to, we plug it back into f. So what is f of 0? Well, remember the graph. The function is defined. Actually, I don't even need the graph, actually. We have the linear function which is defined for when x is less than or equal to 6. Or we have the quadratic function when x is greater than 6. Since we need to plug in x equals 0, that is for the linear graph, isn't it? Because it's inside this inequality. So I'm going to plug in x equals 0 into my linear function because that is the value of x, which is 0, which is defined for that. So that would be, I'm going to say f of 0 is going to be equal to 9 plus 3 lots of 0, which is equal to 9, right? So now I know that f of 0 is equal to 9. I need to now plug 9 back into my function. Now remember, our input is 9 now. Look at your inequality. X is less than or equal to 6 is for the linear function. X is greater than 6 for the quadratic. Since 9, which is what we're going to put into our function, is greater than 6, I now have to plug 9 into the quadratic function. So that's what I'm going to do. So I'm going to say f of 0, right, is the same as f of 9, right? And plugging in 9 into the quadratic function is going to be 36 minus 1/4 and then 9 squared. And I'll just put this into my calculator to see what we get. We just zoom out a bit as well so you can see it too. So that would be 36 take away 1/4 and then 9 squared. And that is equal to 63 over 4. So that is our final answer. And that's it. That's question 8 finished. Okay, so question 9 says, given that y is equal to 4x times 3x minus 7 to the power of 5, show that dy dx is equal to 4 times 3x minus 7 to the power of 4 times by cx plus d, where c and d are integers to be found for 4 marks. So we're given y that asks us to show what dy dx is. So we need to differentiate. Now, upon further inspection, if you look at the actual expressions themselves, you've got a product of 2 separate functions, don't you? Right? because essentially you don't want to expand that, do you? It's quite long. So we're going to use the product rule to differentiate this. And then as well as that, if you look even closer, this is a composite function. When we get to this part of the differentiation, when we're doing the product rule, we're going to have to apply the chain rule as well. So there's a couple of things going on here. So just be aware of these types of questions. So firstly, what is the formula for the product rule? If y is equal to uv, then dy dx is going to equal u v dash plus v u dash. So you keep one the same, differentiate the other, alternate, add them together, and that's pretty much it. So firstly, our u, let me write out the question again. Y is equal to 4x 3x minus 7 to the power of 5. U is going to be 4x. V is going to be 3x minus 7 to the power of 5. Now, let me just zoom in a bit and then start differentiating. So, U dash, if I differentiate that, that's just going to be 4. Now, V dash, how do I differentiate that? This is a chain rule problem. Now, by the time you get to the exam, you should be able to do this very, very quickly, but I will run through how it works, and then I'll do the very quick method. But yeah, so what I'm going to do is I'm going to differentiate that. But first, I'm just going to put 1 here. I'm going to rewrite this as y, and I'm going to just write 3x minus 7 to the 5. Now, remember your chain rule formula. If dy over dx, right, or dy over dx, I should say, is equal to dy over a connecting variable, which is what you make a chain with, du, times by that same du over dx, right? So in this case, what you need to do is just identify what your u is, and it's always going to be the thing inside, right? The thing that makes it a composite function, right? So I'm going to set u equal to 3x minus 7. That means that if I were to differentiate that du over dx, right, that would equal 3. Now, since u is equal to 3x minus 7, then I can actually write y in terms of u, couldn't I? In terms of u, right? Which would be y is equal to u to the power of 5. And then now if I differentiate that, that would be dy over du. Remember, it's with respect to u now. Would be 5u to the 4. This is just standard differentiation. So now we've got everything we need. We can plug it into here. So it's going to be dy over du, which is 5u to the 4, multiplied by du dx, which is 3. So dy over dx is going to be 15u to the 4. But remember, we need it in terms of x, which is fine because we know what u is equal to. It's 3x minus 7. So it's 15 times 3x minus 7 to the power of 4. Now, this is just a formal way of doing the chain rule. By the time you get to the exam, you shouldn't be doing it this way. You should be doing it very, very quickly. So I'll show you how that works. So what I'm going to do is let me move this to the side now, and then I'll do it the quick way, which is the way you should do it in your exam. So let me just move it to the side a bit more. So it's there, and then, okay, perfect. So now, if I'm in an exam and I'm doing the exact same thing, all you need to do is this. We've got this here. We can see it's a chain rule problem. It's something to the power of 5. Differentiate that normally. Just forget about this 3x minus 7. You're going to bring the 5 to the front. Keep that the same. Take 1 away from the power. And then you multiply by the derivative of whatever this is. When you differentiate 3x minus 7, you get 3. So therefore, it's just 15 times 3x minus 7 all to the power of 4, which is how all of you should be doing it when you get to the exam. I'll just show you the other way, just in case anybody is a bit unfamiliar or just needs a bit of reminders. Anyways, remember the question. We're trying to figure out what dy dx is. So we are now in a position to apply the product rule, aren't we? So dy dx is equal to uv dash. So uv dash are these two, plus vu dash, which are those two. So it's going to be equal to, all right, dy over dx here. That will equal uv dash, which is going to be 4x times by the 15, and then 3x minus 7 to the power of 4, plus these two, vu dash, which is going to be 4, and then 3x minus 7 to the power of 5. Now, this is a show that question. Always have at hand what you're trying to show. I always say that when I'm doing show that questions, always just keep it as a reference so you can kind of see where you need to go in terms of the algebra you need to do. So I'll put this here. So I'll just keep this as a reference. So we need to get here. Now, when I look at this, I can see that the show that is a product, right? We have a sum at the moment. So that tells me, well, how do I go from a sum to a product? I need to factorize, don't I? Right? So doing this, what can we do? We can, 4 times 15 is 60, and which I could simplify, but what I'm going to do is I'm just going to pull out, we can see there's a common factor of 4 here, isn't there? Yeah, so I'm going to pull out that 4, so that means I'll have a 4 here, and then what else can I pull out? Well, I've got this factor of 3x minus 7, and I've got it there. This one is to the 4. This one is to the 5. So this one has an extra 3x minus 7. So I can pull out 4 of those factors from both, can't I? So I can pull out 3x minus 7 all to the power of 4, can't I? So that would be that. And then what would be inside the bracket? Well, what haven't I touched? Well, I haven't touched the 15 and I haven't touched the x. So for the first term, there would be a 15x there. And then I've touched that 4. I haven't grabbed the extra 3x minus 7 factor, have I? So I can put that there. So it'll be 3x minus 7 like that. And I'll put that in a bracket so it's just kind of clear to see. But because we're adding it, I don't actually need the bracket, do I? So let me just put it a bit closer. I'll do it like that. So this is it factorized. We've got the 4, 3x minus 7 to the 4. We just need to simplify the expression inside the last bracket. So that's going to be 3x minus 7 to the 4. 15 plus 3 is 18, 18x minus 7. And as we can see quite clearly, our C must be equal to 18, and our D must be equal to minus 7. So that is done. Part A is done. Fantastic. So what does part B say? Part B says, hence, find the range of values of x for which y is decreasing. Now remember, y is decreasing, y is increasing. What does that mean? It means that your gradient, the rate at which your function is changing, is just positive, right? If it's increasing, if it's decreasing, it means it's negative. So essentially, since it's decreasing, dy dx must be less than 0. So I'm just going to grab that here. I'm going to paste part B here. And then since y is decreasing, and remember, the gradient must be negative, right? So we're just going to say then that dy dx has to be less than 0 here. Now we've got dy dx, don't we? So I'm going to grab this here. And because this is dy dx, that must mean that this has to be less than 0. So we need to solve this inequality. Now, whenever you get something like this, it looks a bit tricky because you've got a power of 4 here. Probably thinking, maybe, how do I go about doing this? Just inspect it, right? This expression on the left-hand side needs to be less than 0. Well, we've got a product of a couple of different expressions and numbers, right? If you just inspect it bit by bit, 4 is a positive number. I'm just going to put a plus there. 3x minus 7 to the power of 4, right? The power is very key here. It's an even power, which means you can rewrite it as a square, essentially. Even powers can't be less than 0, can they? Because essentially you're squaring it. So this expression here is never going to be negative. It's going to be either 0 or more, right? So we can just say, we just put plus for now. So I'm just going to plus, 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 right? We're timesing two positives essentially together, right? Now, this one is a linear expression. This can be negative, can't it? Right? So for this entire expression to be negative, it must depend on this yellow factor because these two are going to be positive no matter what they are, right? Obviously, that could be 0 for a certain value, but we want it to be negative, right? If it's 0, then the whole thing is 0. So we're not going to look at this as being 0. So we're just going to treat it as positive. So we need to ask ourselves, right, how can this be negative? Well, if I have a positive times a positive, the only way for this to be negative is if this factor here is negative, right? Because two positive will make a positive. Positive times a negative will be less than 0. So for this entire expression to be negative, I must have the 18x minus 7 to be less than 0. It would have to be negative. Let me write it here so it's clear. 18x minus 7 must be negative. Right? So essentially, remember the question asks us to find a range of values. That just means solving an inequality. So we just need to solve that. So it's going to be 18x. It's going to be less than 7. That means that x has to be less than 7/18. And that is going to be our answer for part B. And that is it. Question finished. Okay, so question 10 says, show that the sum from n equals 3 to infinity of 5 over 6 to the power of n times the cosine of 90n degrees is equal to 625 over 2196. So 5 marks, definitely a tricky question. With these types of questions here, right, what you want to do is firstly, sigma notation. You need to make sure you understand how sigma notation works. But essentially, you're basically just trying to formulate a pattern, right? So if I'm faced with a question that's in an exam, what I would do is first maybe formulate the first couple of terms that I would be summing in this entire summation, right? So firstly, we start at n equals 3. So if I was to sum this, I'm just going to say this would be equal to, it would be equal to 5 over 6 to the power of 3, n equals 3, that's the first value, times the cosine of 90 times by 3. And then the next one would be, well, n equals 4, isn't it? So 5, 6 to the 4, and then cosine of 90 times by 4. And then I'll just do a couple more. 5, 6 to the 5, cosine of 90 times by 5. And then I'll do one more and I'll do it here. 5, 6 cosine, 5, 6, sorry, to the 6th, cosine of 90 times by 6, and so on and so forth. So what I would do essentially is just maybe evaluate a couple of these just to see what happens, right? So firstly, because 5 over 6, the power will get a bit big, I'm going to keep 5 over 6 to the power of 3 as is. I'm going to just only evaluate the cosines, right? Because we know with the cosines, you can think of it as 4 parts from 0 to 360. It's going to go from 1 to 0 to -1, back to 0 to 1. So the signs are going to alternate, and you're going to see what I mean by that. If I do cosine of 90 times by 3, I get 0 there, right? So what I'm going to do is I'm going to put a 0 in red right here. And then let's do this one. 90 times by 4. Let me just put this here. 90 times by 4. So what I'm doing is I'm just evaluating the cosine bit. That's going to be a 1, right? So that is 0. That's 1. What is 90 times by 5? It's 0, right? So that's going to be a 0. And then what would this be? I'm sure you guys will be able to guess now. 90 times by 6 will be -1, right? So it becomes -1. So the first term is 0, then it goes to 1, then it goes to 0, then it goes to -1. So I'm sure if I was to just do it one more time, let's just do 5 over 6 to the 7 times by cosine to the 90 times by 7, right? What would that be? Well, let's do 90 times by 7. That gives us 0 again. So we can see that there's actually a pattern here, right? There's like a 4-term cycle. It goes from 0, 1, 0, -1, and then back to 0. Now, if I just inspect this, right, remember, we're trying to sum all of these. What we've noticed is that a couple of the terms in this series is just going to be 0. So I would just cross them out, right? So, and that, as you can see, that's going to be for odd powers, right? When it's 3, that is 0. When it's 5, that is 0. When it's 7, that is 0, right? So the only powers that generate an actual numerical value are going to be the even powers. So what I'm going to do now is say, okay, well, fine. Well, remember, I'm trying to sum this. I'm trying to show I get this. So far, I'm going to say that this is going to be the term here. It's going to be my first term, kind of, essentially, because the first term was actually 0. So this is going to be my quote unquote first term. It's going to be 5 over 6, like that, to the power of 4. Now remember, that was 1, isn't it? The cosine of 90 times by 4 is the cos of 360, which is 1. So I'm just going to put a 1 here, like that. And then what would the next term be? The term right after it was 0. I'm going to go to this one, which is to the power of 6, like that. And then that's going to be cosine of 90 times by 6 is -1. And then we can see what's happening here, isn't it, right? Because remember, the next one, it goes 0, 1, 0, -1, 0. The next one's going to be a 1, isn't it? Right? And then it will be a 0, and then it will be a -1, and so on and so forth. So what we have here is a pattern. The actual series itself, the series that we're trying to find out, it starts at 1, goes to -1, and then 1, and then -1, right? Because there's the terms which have a 0 we can just ignore. So essentially, it's just going to be like this. The next one's going to be 5 over 6 to the power of 8. And then that will be a 1 if you just follow the pattern. And then the next one is going to be 5 over 6 to the power of 10. And then that would be a -1, isn't it? And you could always just double check, isn't it? Right? Remember, n equals 3 is your starting value. If I was to plug in n is equal to 10, for example, right? The cosine of 90 times by 10. Remember, we've said here that when it's 10, it's -1. Times that by 10, we get -1. So it definitely works. So essentially what we've done is we've broken down this very extreme series question into parts so that we're able to formulate a pattern, right? We've noticed that there are terms that are going to be zero that we can cancel out, and essentially it's just this here. So we need to add all of these, and we need to show that we get that expression. So again, a couple of things with this question. It's sigma notation. The top value is the infinity symbol. That's an indicator as to what type of series you're dealing with. Geometric, right? Sub to infinity. That should be ringing alarm bells. So how can we actually just show that this is geometric? Well, firstly, if I was to just evaluate this again, just so it's super neat, it's going to be 5 over 6 to the power of 4, right? That one we can just remove. And then it's going to be plus, and I'm just going to put a minus here, right? For that minus. And it's going to be like that, 5 over 6 to the 6th plus 5 over 6 to the power of 8. And then plus, and then minus 5 over 6 to the power of 10, and so on and so forth. Now, what do we have here? Well, we've definitely got a first term, right? Which is going to be 5/6 to the power of 4. Now, how do I go from one term to the next? Well, firstly, the series is alternating in sign. So I definitely need to times by a -1. So I'm going to just put a minus there for now. And then, well, how do I go from the actual numerical value to the next one? The only difference is this power. It's going up in twos now. So to times it, I'm going to have to times by 5/6 to the power of 2 for me to be able to get to that 6 and then to the 8 and so on and so forth. So our common ratio is going to be r is equal to minus and then 5 over 6 to the power of 2. So now we have a first term, we have a common ratio. The question asks us to find the sum to infinity of this expression here. So we're just going to use the sum to infinity formula now with these, aren't we? So it's going to be sum to infinity. Whoops, write that a bit neater. Sum to infinity is going to be a over 1 minus r. The first term is going to be 5 over 6 to the power of 4 over 1 minus, and then minus, remember that minus is on the outside, by the way, 5 over 6 to the power of 2, which you can just write at the bottom as a plus, isn't it? Like that. So your answer is going to be whatever this is here. So let's plug this into our calculator and let's see if we get 625 over 2196. So let me just do that here. My calculator is there. And then let me just put this here. We're going to be 5 over 6. Whoops. 5 over 6 to the power of 4. Like that. And then 1 plus 5 over 6 squared. And that gives us 625 over 2196. So we've done it. And that's it. Definitely a tricky question. If you've done your revision, you should recognize that this question is actually very similar to paper 2 of the 2021 series, and that actually got inspiration from it. I think it's a very good question because it really enables you, or it forces you to be able to spot patterns and make sure you really understand how sigma notation works, formulating patterns. So yeah, I just got the question. I kind of tweaked it, made it a bit trickier, but yeah, hope that's okay. But yeah, that's it, and that is question 10 finished. Okay, so question 11 says express 8 sin x minus 15 cos x in the form r sin x minus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. Give the exact value of r and give the value of alpha in radians to 4 significant figures for 3 marks. Okay, so firstly, I've got the question A summarized. Let me just make sure my calculator is in radians. It is, which is good. Okay, so standard part A of these types of harmonic identities questions, we need to use our addition formulae. So I'm going to write out here again. We've got 8 sin x minus 15 cos x, right? And then this is equal to, because we can write in the form of r sin x minus alpha. Now what I'm going to do is I'm going to use the compound angle formula to expand the sin x minus alpha. It's going to be sin x cos alpha minus cos x sin alpha, isn't it? Then now I can expand the bracket, so it becomes r sin x cos alpha minus r cos x sin alpha. Like that, and obviously this is equal to 8 sin x minus 15 cos x. Like that. Let me just make this a bit more legible. So like that. Perfect. Okay. Now when you get to this step here, it's just a matter of equating the coefficients. So this 8 here, which is multiplying the sin x, would have to be equal to the expressions multiplying the sin x on the left hand side, right? Because we're equating the coefficients. So what I can say here is that the r cos alpha must equal 8, right? Because this here must be timesing the sin x. It is timesing the sin x, and it's the same on this side. And it's the exact same thing on the 15 as well. They're both negative, so I can ignore the negative, but the 15 is going to be equal to the r sine alpha, like that. So I'm going to have r sine alpha is equal to 15. And then now to get alpha and r, this is very, very simple. I'm going to divide bottom by top. So it's going to be r sine alpha on the top here, because I want to make tan, over r cos alpha on the bottom. And that will equal 15 over 8. Now from here, we can see that the r's are going to cancel. Sine over cos is tan. So tan alpha is going to equal 15/8. So that means I can calculate what alpha is. So I'm just going to do that now. So alpha is going to be the tan inverse of 15 over 8, which is equal to 1.0808. They want it to four significant figures, don't they? So that's going to be 1.081, isn't it? Yeah. So that means that alpha is going to equal 1.081. So that's fine. And then we need r. Now, when you're here, we've got equation 1, you've got equation 2. You're going to square both of them and then add them. And then, yeah, you will see what we get. So if I square the first equation, it's going to be r squared cos squared alpha, right? If I square the second one and add it, it's going to be r squared sine squared alpha, like that. And then that will equal 8 squared plus 15 squared. Take out an r squared from both. We're going to get cos squared plus sine squared in the middle, which you know is going to be equal 1, isn't it? So we get this there. And then, yeah, that's just one from our trig identity. So we have r squared is equal to 8 squared plus 15 squared. So therefore, r is going to equal the square root of that, 8 squared plus 15 squared. And that will equal, square root is there, 8 squared plus 15 squared. And that is 17. So r is 17. So what we can say now, to finish off, we could just say r is equal to 17. And alpha is equal to 1.081. And that is part A finished. Okay, so part B says f of x is equal to 15 over 41 plus 16 sine x minus 30x, where x is greater than 0. Part B says find the minimum value of f of x, and double I says to find the smallest value of x at which this minimum value occurs for 4 marks. Okay, so this is very common in the exam, whereby you've got part A, we've done the identities, we've figured out what r is, figured out what alpha is, and they give you the next part, which if you look very closely is linked to the part A, right? Because if I grab this part A, let me just grab this expression here, and let's just remind us of what we've actually done, right? We've used this expression. Whoops, let me get it again. We've used this expression 8 sine x minus 15 cos x, right? And we have said that this is actually equal to r sine x minus alpha, isn't it, right? Whereby our r was 17 and our alpha was minus sorry, our alpha was 1.081, isn't it? Yeah. Now, if I inspect the function that they've given us in part B, I can see a 41 there, but what I do notice is that I've got a sine and I've got a cosine here, right? I've got 16 and I've got 30, right? That's just two lots of these two, isn't it? Right? So what we can do here is say, well, if I've got this there, well then, if I times both sides by 2, I'm going to times this by 2, 16 sine x minus 30 cos x. That will give me 34 sine of x minus 1.081, isn't it? So with that being said, you want to substitute, right? You always want to substitute. That's the whole point of this topic, essentially. You basically want to rewrite this expression in terms of one trigonometric identity, or one trigonometric expression, I should say, right? And right now it's in terms of sine and cosine. We don't want that. We want it in terms of one. So what I'm going to do is, because I know 16 sine x minus 30 cos x is equal to 34 sine x minus 1.081, I'm going to just literally replace it. I'm going to say f of x is equal to 15 over 41 plus 34 sine of x minus 1.081. Perfect. All right. Now, what does the question ask me to do? It says I need to find the minimum value of f of x. So I need to minimize this function here. Now, this function is a fraction. So just think about it logically, right? I want this fraction to be as small as it can be. Then I would need to be dividing by the biggest number possible, right? And the reason I'm only looking at the division is because of the fact that the numerator is a constant. I can't do anything about the 15. However, the denominator has a variable and it has x, right? So the function depends on what x is, which is on the denominator. If I want it to be as small as it can be, I would want the denominator to be as big as it can be. I want to divide by the biggest number possible. So essentially what I would need to do is work out what the maximum of this expression here is, because essentially this 41, right, and this 34 are constants. I can't do anything about that. What I can do something about is this function here, because it's a variable function, isn't it? It varies, right? So if I want, again, I want, let me write, I want the minimum, I want the min of f of x, right? So I would want 15 over 41 plus 34, and I'd want to times by the maximum of this, because that will give me the biggest denominator overall, and that will minimize the fraction overall, which will minimize the function. So what would be the maximum of this sine function? Well, if you look at it, this minus not this minus 1.081 doesn't stretch it vertically. It's literally just a horizontal shift to the right, isn't it? So it's not going to affect the maximum minimum. So it's going to have the same max or min as the original sine graph, which is going to be between 1 and -1. So what I'm going to do is I'm going to say I want the max of I'll just write here, max of sine of x minus 1.081, and that is going to equal 1, right? So the minimum of the function is going to be when that expression is 1. So it's going to be 15 over 41 plus 34 times by 1, which is just 15 over 41 plus 34. And that is just 15 over 75, which is a fifth. So therefore, the minimum of f is 1/5, right? So I'm going to just write it here. Min of f of x is equal to 1/5. And naturally, they didn't ask in this case, but I'm sure you'd be able to figure out what the maximum would be. You would just swap this over to a -1, wouldn't you? So I'll write it here. They didn't ask it, but it's just good to understand how these works. The maximum of f of x, right? Well, that would mean that I would want the sine function to be negative. I would want it to be as small as it can be, because I want to maximize the fraction. The way you maximize a fraction is you want the denominator to be as small as it can be, isn't it? So it would be 15 over 41 plus 34 times -1, isn't it? Which is just 41 minus 34, which is 7, isn't it? Yeah, that's 7. So it'll be 15/7. So the minimum of this function is a fifth. The maximum is 15 over 7. Again, they didn't ask for the maximum, but I just want to put in here. Anyway, so we've done part I of part B. Part I says we need to find the smallest value of x at which this minimum value occurs. Well, remember what we said. This minimum value occurs when sine x minus 1.081 is equal to 1, right? So what we need to do is solve this to figure out what the actual value of x is, and we want the smallest value. Remember, x is greater than 0, so it's the first positive value. So what I'm going to do for I is I'm going to say that we want this to equal 1, don't we? So minimum, because we want the minimum. The minimum occurs when sine of x minus 1.081 is equal to 1. So I'm going to solve that and see what I get. So solving that is going to be sine inverse of that. So sine inverse of 1 is pi over 2. Of course it is. So it's going to be x minus 1.081. That's going to equal pi over 2, right? Now, to get what is this, by the way? Pi over 2 is like 1.6, isn't it? So I'm gonna add it on to see what I get for the next value. Yeah, 1.57. So I'm going to do answer, add 1.081 to see what value of x I get, which is that. So it's going to be x is equal to 2.65. What was the degree of accuracy? If it doesn't state, then there's three significant figures, so I'll leave it like that. It doesn't say, so I'll just leave it as 2.65. Perfect. Okay, so that's going to be the first positive value of x. So this is our answer. Now, part C, it says state the y coordinate of the minimum points on the curve with equation y equals 2f of x minus 5, where x is greater than 0. It's only one mark, right? So we want the minimum point of a transformation of this graph. Now, what's happening here? Well, it's been stretched by 2, right? And then we're just going down by 5. There's nothing else happening here in terms of horizontal or anything like that. And even if it was, it doesn't really matter anyway, because we're looking for the minimum point, the y coordinate of the minimum point, right? Which wouldn't be affected by horizontal movements. But yeah, so all you're gonna do is remember the y coordinate. You know what I'll do? Because it's gonna be an infinite amount of solutions, isn't it, for the minimum point. So what I'll do is, let me just go back here, and I'm gonna just say for part C, right? We know that a minimum, right, occurs at when x equals to 2.65, and the y value was what was it again? It was a fifth, wasn't it? Like that. And this is f of x. Yeah. So if I want 2f of x take away 5, well, what happens? Well, firstly, let me just do it like this. So it's bit by bit. Firstly, if I want 2f of x, what would happen? Graph transformations, it's only the y coordinate that's affected here. I'm going to times the y coordinate by 2, like that. So that would mean that now it will become 2.65 times 2 over 5, 2/5. And then now, remember, this minusing of 5 is a vertical translation, isn't it? It's going to go down by 5 units. So we're going to take 5 away from the y coordinate. So it'll be 2.65, 2/5 take away 5, isn't it? Which is going to be, I'll just put this in my calculator, 2 over 5 take away 5 is going to be minus 23 over 5. So therefore, that minimum point there is going to be minus 23/5. And the y coordinate is minus 23/5. That's what they asked us for, the y coordinate. So that would be that. The next question, it says state the smallest value of x at which a maximum point occurs for the curve of equation y equals minus f of 2x. Now, they asked us for the maximum point this time. We've been dealing with minimum so far. However, look very carefully. What's happened to the graph? That minus means that the graph has been reflected in the x-axis. So the minimum value that we had before, right, is going to now be the maximum once it's reflected. So there's nothing else you really need to do, which is only why it's one mark. So I'll put this here. So I'll just say for part D. No, that was part D, or was it C? Is it C and D? Oh, okay, C and then D. Okay, cool. So yeah, for part D, originally, right, with f of x, right, the minimum was at, we're using this point as reference here, so 2.65, and then the minimum was a fifth, wasn't it, right? That was the minimum, right? Now, if I reflect this in the x-axis minus f of x, right, then the coordinate would be 2.65, and then I will times that y coordinate by minus 1, right? And because it's reflected in the x-axis, this now becomes the maximum, doesn't it? Yeah. So we're here now. The maximum is just the reflection of the minimum originally. Now, that's not it though, because it does say f of 2x, isn't it? Right? So what does that 2 do to the graph? Remember, that's just going to be a horizontal compression by a half, isn't it? Remember, your graph transformations, super, super important. So f of 2x, yeah, the max will still stay the same, but I would have to divide this by 2, wouldn't I? So let's see what we get when we do that. 2.65 divided by 2 is going to give me 1.325, isn't it? So that x coordinate there is going to be 1.325. Did it ask for degree of accuracy? It doesn't, again, so I'll just do it to three significant figures. So we're going to say x is equal to 1.33. And that is it for part D. And that's the question finished. Okay, so question 12 says, use proof by contradiction to prove that root 11 is irrational. You may assume that if k is an integer and k squared is a multiple of 11, then k is a multiple of 11 for 4 marks. Okay, so proof by contradiction comes up every year. We know how it works. We always want to assume the opposite, right? And then in our working out in our algebra, we're looking for a contradiction, and that will prove what we're trying to prove, right? So in our case, we're proving that root 11 is irrational. We're going to assume the opposite. We're going to assume root 11 is rational, right? An irrational number can be expressed as a fraction, isn't it? So what that actually implies is that root 11 will equal some integer a divided by some integer b, right? A divided by b. And as well as that, what you also need to state is because we're expressing it as a fraction, we want to make sure that it's in its simplest term. So what we're also going to say is that a and b, right? These are integers. And as well as that, a and b have no common factors, right? So a over b is in its simplest form. So no common factors. Okay. So we're here now. Now let's do a bit of algebra. We know that root 11 is equal to a over b. Let's square both sides. If I square both sides, I'm going to have 11 is going to equal a squared over b squared. And then what I'm going to do is I'm going to get an expression for a squared, right? By timesing by b squared. That would mean that a squared is going to equal 11b squared. Now, we can see quite clearly a squared is 11 times some integer, right? Which would mean that a squared is a multiple of 11, isn't it? Right? So I'm going to just say here, a squared is equal to 11 times an integer, right? Which implies that a is a multiple of 11. A squared is a multiple of 11, sorry. All right, this of 11. And what I'll do is let me just make it so it's neat. Let me bring this over there and then bring that. Whoops. No, let me go back. I'm going to grab all of it like that. Hopefully, yeah, that grabs all of it. Good stuff. And put it there. Perfect. Right? Now, we've seen that a squared is a multiple of 11. We can assume that if k is an integer and k squared is a multiple of 11, then k must be a multiple of 11. So what we can say here is that from that assumption, a is also a multiple of 11. A multiple. All right, multiple for short of 11. All right, so a is a multiple of 11. Right. If a is a multiple of 11, then surely I can express a as a multiple of 11, right? Literally, I can write as 11k, right? Where k is some integer. Now, if a is equal to 11k, what I'm going to do is I'm going to put it back in here and see what I get and use algebra to maybe get an expression for b now. So with that being said, it's going to be 11k, right? All squared, and that will equal 11b squared, like that. Squaring both sides, I'm going to have 121k squared is going to equal 11b squared. And then now b squared, I'm going to just divide both sides by 11. And that would be 11k squared, right? If I divide both sides by 11, I'm going to get 11k squared. Now, what does that show me? Well, b squared, right, is quite clearly a multiple of 11, right? Because it's 11 times an integer, right? And then with that being said, right, this also implies that b is a multiple of 11 with the assumption that they gave us in the question. B is a multiple of 11. Right. Now, we've shown algebraically that A is a multiple of 11 and B is a multiple of 11. There's a problem there. There's a contradiction because they have a common factor of 11. So let me actually write that. I'm going to write A and B both have a common factor of 11, right? Now, remember what we said at the beginning of our assumption. A and B have no common factors. This is a contradiction. So this is what we've done. We've used algebra to assume the opposite. And in our steps, we've come to a contradiction. That can't be true. So therefore, that would prove that root 11 is irrational. So what you're going to say here now is this contradicts the fact that A and B have no common factors. And so therefore, this implies, or therefore, root 11 is irrational. So always make sure you finish with your statement, right? And that is it. And that will give you the 4 marks. Okay, so question 13 says, show that cos 2x over sine x plus sine 2x over cos x is equal to cosec x for 3 marks. Now, trigonometric identities always comes up. You get a show that in your part A, we have to show a certain expression is equal to something else. And in part B, it's a hence. And then you use what you've done in part A to solve part B. Comes up all the time. So make sure you know your trig identities extremely well. Make sure you've memorized them off by heart. It's no good just looking at the formula book because not all of them are actually in the formula book. But yeah, that's pretty much it in terms of part A. So let's actually do it now. Now we're doing a show that, and what I always like to do when I'm doing this trigonometric show that is I always look at what they want me to get to. So I need to get a cosec x. Now remember, from your reciprocal functions, you know that cosec is 1 over sine. So for me, I need to get 1 over sine x, isn't it? Because that's what cosec x is equal to. 1 over sine x is equal to cosec x, right? So I need to get 1 over sine. So firstly, what that tells me is that I would want to rewrite everything in terms of sines if I can, right? And another thing is that if I look at the angles on the left-hand side, on the top, on the numerators, these are 2x's. I don't want 2x's because the show that has just an x. So I'm going to maybe use some trigonometric identities to get rid of those angles which are being times by 2, right? So firstly, cos 2x. When you see cos 2x, straight away, your mind should go to the double angle formula. Now, there are 3 versions of this formula for cos 2x. We've got cos squared x minus sine squared x. And then we get the other 2 by rewriting cos squared x as 1 minus sine squared and sine squared as 1 minus cos squared. So I'll just write them though. So the second one is going to be 1 minus 2 sine squared x. That is when I change this to 1 minus sine. You can try it yourself. It's a good exercise. And then the third one is when I change sine squared x to 1 minus cos squared x. You're going to get 2 cos squared x minus 1. Now, remember what we're trying to do. We're trying to show that we get 1 over sine on the right-hand side. We want sines, right? So for me, that tells me that I'm going to pick this identity to replace out of the 3, right? So with that one being said, I'm going to write this as cos 2x, which I know is 1 minus 2 sine squared x. Like that. That will be over sine x. And then plus, and then sine 2x, right? Sine 2x is another double angle formula. This is 2 sine x cos x. So again, because I want just 1x, I don't want 2x's, I'm going to replace it with that. So it's going to be 2 sine x cos x. And then this will all be over cos x, isn't it? Now we're here, we're trying to get 1 over sine. Well, what happens? Well, if I look at the one on the right, the term on the right, that cos will cancel with that. I'll just be left with 2 sine here. And then because I want 1 over sine, I can actually get that, can't I? Right? Because I've got 1 minus 2 sine squared x all over sine x. From our fractions, we can just split this, can't we? So it just becomes 1 over sine x. And it will be minus 2 sine squared x over sine x. Like that. And then now we can see that, well, this is just 1 over sine x. 1 of the sine x will cancel with that one. So I'll just be left with minus 2 sine x here. And we still got that plus 2 sine x there, don't we? Which we can see quite clearly cancels. That's going to be 0. It's just left with 1 over sine x, which is cosec x as required. And that's it. And that's question part A finished. Okay, so part B says, hence solve for theta between 0 and pi over 2, cos theta over sine theta plus sine theta over cos theta all squared is equal to 6 cot theta minus 4. Giving your answers to 3 significant figures as appropriate for 5 marks. Now, remember what I said in part A? These questions always follow on from each other. In part A, we solved an identity. We showed an identity, right? We showed that cos 2x over sine x plus sine 2x over cos x is equal to cosec x, right? Now, in part B, we can see quite clearly that that's the exact same expression in the bracket. The only difference is they've changed the x to a theta. So what you want to do is, instead of trying to work with this, you're going to replace this with what you showed it to equal in part A. right? So what I'm going to do is the first thing I'm going to do, and you probably get a mark for that, would just be to replace it, right? So it's going to be cosec all squared. So right here, cosec theta squared, like that. This has to equal 6 cot theta minus 4, right? So remember these types of questions whereby you have to just use your identity that you did in part A and put in part B. And another thing as well, which I always tell my students is, if you weren't able to do a part A and it's a show that doesn't mean you can't access any marks in part B, right? Just make that connection and you're able to have a go at least. So anyways, continuing with this one, we need to solve that equation here. Now, whenever solving trigonometric equations, we want the exact same trigonometric expression, right? We've got a cosec and we've got a cot. We want one. We don't want both of them. What do we use? We've got to use our Pythagorean identities. So remember, sine squared theta plus cos squared theta is equal to 1. If I divide everything by sine squared theta, then that will give me, whoops. If I divide everything by sine squared theta, that will give me sine squared over sine squared will be 1. Cos squared theta over sine squared theta would go there. And that would be 1 over sine squared theta, isn't it? If I divide everything by sine, 1 plus, that is cot squared. And then 1 over sine is cosec squared, isn't it? So we get this identity here, which you should know off by heart, but you can always derive it. I would recommend memorizing it. But yeah, so we're here. Now that means we can replace this, isn't it? Because I have a cot there. That cot doesn't have a squared, so I can't really manipulate it. The fact that that is squared means that I want to replace cosec squared in terms of cot squared. So from there, I'm just going to say that, oh, we've actually got, haven't we? Cosec squared is 1 plus cot, so I can just replace it directly. So that way it just becomes 1 plus cot squared theta will equal 6 cot theta take 4. This is a standard quadratic, so if we move everything from right to left, we will get cot squared theta, take away 6 cot theta, and that would be plus 5, isn't it? And that will equal 0. Quadratic, what two factors of 5 will add to make minus 6? That's going to be a minus 5 and a minus 1, isn't it? And that will be there. That'll be cot theta there. And that will be cot theta there. Which means that cot theta take 5 has to equal 0. Or cot theta minus 1 has to equal 0. Which means that cot theta has to equal 5. And cot theta has to equal 1. Now, remember, we don't have cot on our calculators, so we need to rewrite this. Remember, cot is 1 over tan, so I can rewrite these. Now, remember, since cot is 1 over tan, you can just literally take the reciprocal of both sides. If I take the reciprocal of cot, that is tan, so we'll get tan theta there. And the reciprocal of 5 is 1 over 5. And then this one is just going to be tan theta is going to still equal 1, isn't it? Yeah, so we get that there. And also, just in case, I'll just explain what I've done there. Remember, cot, right, is cos, no, let me not write cos, 1 over tan, like that, and this is equal to 5. If I rearrange this by timesing that up and then dividing by the 5, I'm going to get 1 over 5 is equal to tan theta, isn't it? Which is the exact same thing I've done here. I've just done it quickly. So you can just do it whatever way you prefer, but just thought to just clarify that just in case. So I'll do that there. So we need to solve these two equations, and the range was, let's just check it. It was between 0 and pi over 2. So let's make sure my calculator is in radians, and let's just get started. Yes, it is. So I'm going to do tan inverse of a fifth, and that gives me that number there. So theta is going to equal 0.197 blah, blah, blah. Let me just do a couple more. 3939 blah blah blah, and it's between 0 and pi over 2. So pi over 2 is like 1 point something, isn't it? So that's fine. How do we get the other solutions for tan? We just add on 180, or pi in this case. Yeah, so if I add that on, it's going to be outside the range, isn't it? Because we want it to be in between 0 and pi over 2. So I'm not going to get any more solutions there, right? So this is just going to be my answer so far. And then now this one, I'm going to do the tan inverse of 1. And that gives me pi over 4, like that. And then remember, we want to have it in the range of 0 to pi over 2. So if I was to add on pi, it would be outside the range, isn't it? And if And if I was to take it away, I'd be outside the range. So there's only going to be two answers here. There's going to be this one, and there's going to be that one. Yeah. So theta will equal, what was the degree of accuracy they wanted it to? They wanted it to 3 significant figures as appropriate, right? So that one would be 1.97. Sorry, 0.197. 0.197 there. And then this one's going to be theta is equal to pi over 4. So these are going to be your two answers for part B. So that's done. Part C, it says using the results from part A or otherwise find the exact value of the integral between pi over 6 and pi over 4 of this expression here, which is the same expression in part A times a cot x dx. So let me screenshot that and then grab it. Now, remember, we're here. We're trying to integrate this. It even tells you to use the result from part A, right? From part A, we know that this right here, right, is cosec x. Yeah, we're back to x again because it's in terms of x now, which means that they're actually just asking me to integrate cosec x cot x dx between pi over 6 and pi over 2. Pi over 4, sorry. Now, we are here. We're trying to integrate this. Now, sometimes you should know a couple of standard integrals, but maybe you don't. I would recommend you definitely try and memorize them by the time you get to the exam. But if you don't, you always have the formula booklet, right? There is a couple of different derivatives and integrals that you can access from your formula book. And I would really recommend that you guys do that, because even with me, I remember when I did my exam, I can't remember what question I was doing, but I had to integrate tan x. And at the time, I had never seen that before. It never came up in any of my past papers. I looked at the formula booklet and it was there. So this one, this is actually a standard derivative. So if you differentiate cos x, sorry, not cos x, cosec x, right? You're going to get minus cosec x cot, right? This one's in the formula book, which means obviously if I was to integrate that, I'd get back to the start, wouldn't it? Like that. That would give me, that would be equal to just cosec x, wouldn't it? Right? Obviously plus c. Don't forget the plus c. So they're asking me to integrate that without the minus. So that would just mean that this would just integrate to become negative cosec, wouldn't it? Right? So let me just put that here. So that would be negative cosec x. Yeah? Because minus cosec x cot integrates to become cosec. So cosec cot will integrate to become minus cosec. So we're going to integrate minus cosec, and it's going to be between pi over 6 and pi over 4. And now we're just going to plug this in, isn't it? Now remember, cosec is not in your calculator, so you're going to be right in terms of sine. This is just minus 1 over sine x, isn't it? Like that. Pi over 6, pi over 4. So what you're going to do is you're just going to plug this in. So it's going to be, you're going to evaluate now. Minus 1 over sine of the pi over 4. Minus, and then minus 1 over sine of pi over 6. Like that. And then obviously, just putting that into the calculator, see what we get. This is going to be a plus, isn't it? It's going to be a plus. Let's do it. Minus 1 over sine of pi over 4. That is minus root 2. So all of that is minus root 2. And then this one, so I've already made it a plus, right? So I'm going to just plug in. Let me just do it so it's super clear. 1 over sine of pi over 6. So I'm just going to plug in 1 over sine of pi over 6 now and see what I get. So it's going to be 1 over sine pi over 6. Like that. And then that gives me 2. So it's minus root 2 plus 2, or 2 minus root 2. And that is it. And that is question 13 finished. Okay, so question 14 says find the integral of x squared e to the x dx for 4 marks. Now, it doesn't say much, but what you should identify is what type of integration problem this is. Now, you've got a product of two completely different functions, so that is an indicator that this is a integration by parts question, because of the fact that it looks like a product rule question, and the product rule or integration by parts is actually derived from the product rule, right? So they kind of are one in the same if you kind of think about it. So again, this is an integration by parts question. So let's get started. So let me just write this here. So part A, or is it part I? Part I, doesn't matter. AI doesn't matter. I'll just put I. Yeah, we're integrating x squared e to the x dx. Now we know that we're using by parts. What is the formula? Let's recall it. If I want the integral of v du dx, this is just equal to uv minus the integral of u dv. So essentially, we need to pick something to be v to differentiate and something to be du to integrate. Now, a good rule of thumb is always just choose an expression that would result in a simpler expression, right? So, for example, if I was to differentiate x squared, the degree would decrease by 1 to become an x power, isn't it? So we're going to choose that to be our v. V is going to equal x squared, and that would mean that dv over dx would just be 2x. So it's a bit simpler now. The power has dropped by 1, and that would mean obviously what we're choosing to integrate is going to be e to the x, right? Du. And obviously when you differentiate or integrate e to the x, you get the same thing. So it makes sense to choose this as what we choose to be v and what we choose to be du. So in that case, when we integrate e to the x, we get e to the x again. And now it's just a matter of just applying the formula. So uv, right, is going to be these two. So I'm going to times these two together, and I'll put the x squared first. So it's going to be x squared e to the x, right? And it's going to be minus the integral of these two, u dv dx, which is going to be 2x e to the x dx. So we're here. Now, we need to integrate this. Again, we have to use by parts because we've got a product of two different functions again. Now, you do get these types of questions where you have to apply by parts twice. Again, it's just the same process. So what I'm going to do now is I'm just going to write the integral of 2x e to the x on its own now. Now, same thing. I'm going to choose this to be the thing I differentiate. So I'm going to say b is going to equal 2x, and then I'm going to say that du over dx is going to equal e to the x. Like that, and then dv over dx is going to be 2 now, and then u, when I integrate that, is just going to be e to the x, and then I'm just going to apply the same formula again. So in that case, what I'll do is I'll just do it up here because I've got the formula on top here. So it's going to be uv, it's going to be these two again. So it's going to be 2x e to the x, 2x e to the x minus the integral of u dv, these two. It's going to be 2 e to the x dx. And then now there's no x in front of the e to the x now. So this is just a standard integral, isn't it? So in that case, it's just going to be equal to 2x e to the x minus, and then when I integrate that, well, the 2 I can just bring to the front. And then when I integrate e to the x, I get e to the x again, don't I? So it's just going to be that plus c, right? And obviously this isn't our final answer, but we're just going to use this and we're going to put it over here, aren't we? We're going to replace it with here. So that means that our final answer, let me just grab this here. I'll just grab this here. Paste it here. Like that. Our final answer is going to be, let me just grab this because that's what we're going to replace it with. This here. It's going to be x squared e to the x, right? And I'm going to minus this, aren't I? So I need to put a bracket around it because I need to protect it. And then obviously I'm going to put plus c, like that. So therefore, our final answer for the integral of x squared e to the x dx, sorry, x squared e to the x squared e to the x dx is going to be equal to x squared e to the x minus 2x e to the x plus 2e to the x plus c. And that will be it. Sometimes they can ask you to do it in a certain form. So for example, from here, algebraically, we could take out e to the x, and then we could have an x squared minus 2x plus 2, couldn't we? Plus c. So that would be fine as well, but they didn't ask you for a specific form. So either one of these two answers would be correct. And that's it. And that's question 14, part I, finished. Okay, so part double I says use the substitution u is equal to root 1 minus 3x to show that the integral of 27x over the square root of 1 minus 3x dx is equal to minus 2 times 1 minus 2x to the half times x plus b plus k, where a, b are integers to be found and k is an arbitrary constant. All right, so integration by substitution, we know how this works. We have some integral in terms of x, which is a bit difficult to integrate as it is. So we use a substitution u to rewrite the integral into something we're more familiar with and we can just apply common integration techniques. So firstly, what I'm going to do is I'm going to write the substitution u equals the square root of 1 minus 3x. Now, with ones like these, there's actually two ways you could do this. I'll do both of them. So first way, I think it's the most conventional way, which most people would do, is we don't really like dealing with the roots, right? So what we could do is eliminate that square root by squaring. So we're going to have u squared is going to equal 1 minus 3x, isn't it? If I square both sides. And then what I want to do is just essentially get everything from x to u, right? So I know what u squared is. It's 1 minus 3x. I've got that there. I can also get an expression for x, can't I? Just by rearranging this. So that would be 3x is equal to 1 minus u squared, right? If I just put that there, and then divide by 3 will give me x is equal to a third minus a third u squared. So I've got an expression for x. I've got 1 minus 3x, that's u squared. And then now I need to figure out what dx is. And that always comes by differentiating your substitution. Now remember, we squared it, didn't we? Right? So if I want to figure out what dx is, I will need to differentiate the left-hand side with respect to x and the right-hand side, right? Now u isn't explicitly in terms of x, right? It's u squared. So we've got to use implicit differentiation here. So when I differentiate u squared, right, with respect to x, I'll differentiate with respect to u first, so 2u, and then I'll multiply by the u over dx by the chain rule, isn't it? And then this will equal, differentiate the right-hand side with respect to x now, 1 will go to nothing, minus 3x goes to minus 3. And then algebraically, I'm going to divide by the minus 3 times by the dx. So 2u du divided by minus 3 is going to equal dx, isn't it? And then I can just tally this up and say that dx is equal to minus 2/3 u du. So now I'm here. I've got an expression for everything now in terms of x. So I've got x, I've got 1 minus 3x, and I have dx. So if I was to just write the integral here again, it's going to be 27. 27 times by x. We know that x is this expression here. So it's going to be 1/3 minus a third u squared. We're going to divide this by the square root of 1 minus 3x, which is u squared. And then dx, which we figured out to be minus 2/3 u du. So now I'm here, I can just go ahead and start simplifying this, can't I? So let me just copy this and bring this down here. Let me do it here. Okie dokie. So what can we do first? Now, let's expand the numerator. Or to be fair, doesn't actually matter, but I'll do this. So I've expanded the numerator, what I can do is say I've got 27 here, and I'm dividing by 3, aren't I? Right? 3 goes into 27 9 times. 3 goes into 3 once. So I can do that there. And what else can I do? I think that's pretty much it for now anyway. So as well as that, we've got the u's, don't we? Because remember, the square root of u all squared is just u, right? So if I put that over u, and I've got 9, and then I've got a third minus that there, u squared, like that, and then I've got minus 2u du, then what will happen is that will cancel with that, isn't it? And then now I'm here. What I do have is if I expand, or you know what I'll do? I'll do 9 times minus 2, that's minus 18. So I'm going to have minus 18, and then I'll have just a third minus a third u squared du. So now I'm here. And then now, expanding this is going to give me 18 over 3 is 6. So minus 6 plus 6u squared du. And now can you see, remember, we started off with this very crazy integral, 27x over root 1 minus 3x. And then we've used a change of variables and substitution to get it into this form now. And this is just standard year 12 integration, isn't it? So integrating this is going to be minus 6u plus 6. And then integrating u squared will be u cubed over 3. And then tidying it up now, that's just going to be minus 6u plus 2u cubed, isn't it? And obviously, don't forget our constant of integration. In this question, they are using k, so I'm going to use k. So we're here. So this is where we're at. Now remember, let's look at the show that. Let's see what they're trying to, what we need to get to. Always use what they're trying to show you as a point of reference. So we're here. Obviously, our integrals in terms of u, we need it in terms of x. Remember the original substitution, this one here. So I'll get both of them actually. So I'll copy this here. And then what I'm going to do is, if I look at what I've got, it's in terms of u at the moment, right? Let me just put this here. Let me put this here. It's in terms of u at the moment, but I want it in terms of x. So what I'm gonna do, just to make things nice, is I'm gonna simplify it in terms of u and then put the u back in at the end. So we need a product, right? We need -2 and then this here and then that and then plus k. So that tells me, because that's a product, I'm gonna have to factorize, and we can do that. If I take out a -2, right, then that would become +3. Actually, as well as that, I can actually take out u, can't I? I could take out a -2u, can't I? So in that case, that would be a 3, and then that would be a minus u squared, isn't it? Like that. And then that would be plus k. So we're here. Remember, we've taken out a -2u. Remember, u is equal to the square root of 1 minus 3x, which is the exact same as 1 minus 3x to the power of half. So that means I'll have -2, and then I'm going to have 1 minus 3x to the power of 1/2, and then times by 3 minus u squared. U squared is just 1 minus 3x. So I'm literally just taking away 1 minus 3x, and do not forget to put your brackets around it when you're taking it away, plus k. Now, doing this, we've got the first two, -2, 1 minus 3x to the half, like that. And then if I expand that, it's going to be 3 minus 1 plus 3x, isn't it? Plus k. And then -2, 1 minus 3x to the half. And then this here is just going to be 3x there. 3 minus 1 is 2, and then plus k. So now if we compare that with what they want us to get to, we can see that it's the exact same form, isn't it? So we can see quite clearly from here that A is equal to 3 and B is equal to 2. And that's it. And that is one way of doing it. Okay, so that's one way of doing it. The second way, which now that I think of it, most people will probably do it this way as opposed to actually squaring it and doing implicit. It's just using the substitution given to you, right? Which is probably what I would do as well, actually. So, yeah, let's go ahead and do it this way. So we know that u is equal to √1 minus 3x. I remember the aim is still the same. We're trying to get everything from x in terms of u. So what I can do is say, well, okay, well, firstly, I've got 27x, right? And now I know what the square root of 1 minus 3x is. This u. So I've got that there. And then I've got dx here. And then what I'm going to do is actually, I'm going to differentiate this from here. So with this though, because of the fact that it's the square root, I need to rewrite this as a power, and it's going to be a chain rule problem, isn't it? Like that. So du over dx, right? If I use this, it's going to be the chain rule. The half will drop to the front. 1 minus 3x. I'll take 1 away from the power, and then I'll times by the derivative of what's inside, and that will just be -3. So therefore, I'm going to have du over dx is going to equal -3 over 2, just bringing the half and the -3 together, 1 minus 3x to the -1/2, like that. And remember, we always want dx, don't we? So what I'm going to do is I'm going to times up the dx and divide by all of this, isn't it? Now, I'll do it bit by bit. If I divide by -3 over 2, then it's just the same as it's the same as times it by -2/3. So there'll be -2/3 there. I'm going to divide by this, so it's going to be I'll do it like this. So it's going to be times and by 1 over 1 minus 3x to the -1/2, like that. And then I've got the du there, and then I'm timesing up by the dx, right? So I've just divided these two like that, and then I've times up the dx, right, to get the dx on its own. Now we can just simplify this a bit. Remember what we have. So let's just tidy this up a little bit. Now this is 1 over, remember, If I do 1 over to a negative power, that is going to cancel. This is just the same as 1 minus 3x to the half, like that. And then du, and then this is dx. Now, remember, u is equal to 1 minus 3x to the half. So I can actually replace that, can't I? So I can say this is minus 2/3, and then u du, right? And then this is equal to dx, right? Because remember, this here is u, isn't it? So now I'm here, I can put that in. So if I put that in there, let's see what we get. Putting that in there, it's going to be the integral of 27x. We're going to get to the x in a moment. Of u, and then times by dx, which is minus 2 over 3 u du, like that. Perfect. Okay. Now we are here. Let's just tidy up the constants, and then we will sort out the x in a moment. So doing this, that will cancel with that. 27 divided by 3. 3 goes into 27 9 times. 3 goes into 3 once. 9 times minus 2 is 18. So right now I'm at minus 18 x du. So now we need to get an expression for x, don't we? So where are we? Remember, this is our substitution. And from here, you can now just square it and then rearrange to make x a subject, can't you? So doing this here, I'm just going to square it. So I'm going to get u squared is equal to 1 minus 3x. And then I'm going to say that 3x is going to equal 1 minus u squared. And x is going to equal a third minus a third u squared. And then I can just put that in there, can't I? So I get minus 18. And then it's going to be a third minus a third u squared du. And then now we just do the exact same thing. So it's going to be now, that will be minus 6. And then plus 6u squared du. And then from this point on, right, it's the exact same as what we did before. So let me just get this here. Where are we? Yeah, right here. So we get to the exact same point here, and then we just literally follow the exact same steps. Integrate, simplify, take it out, and then yeah, just literally do the exact same thing that we did here. So from this point, it's just basically another way of getting to this step here. Yeah, so it just depends on which way you prefer to do it. But yeah, both ways are the same. So once you get to this point, it's just literally just following these steps here again. So there's no need for me to actually do it again. I'll just copy this and put this underneath for the PDF when I do the written solutions. So from here, you'll do the exact same thing as we did before. Integrate, simplify, take out, and that's it. So yeah, it's just another way of doing it. It just depends on what you prefer. Some people don't like dealing with the square root, so they square, but then you have to do implicit differentiation. Some people don't mind. It just depends. So yeah, just thought to do both. So I hope that makes sense. And yeah, that's question 14 finished. Okay, so question 15, the last question of the paper. Part A says, prove by expressing 4 to the x in terms of e that the derivative of 4 to the x is equal to 4 to the x ln 4 for 3 marks. Okay, so with this one, I've explicitly put in bold in terms of e because there is another way to do it, and it does come up in the exam whereby whenever they ask you to differentiate an expression of a to the x or x to the x, they tell you to take logarithms first, which you can do, natural logs, and then do it that way. But it's my paper, so I can do what I like. But yeah, I wanted to just put in terms of e so you can see another way of doing it, right? So how would you do it that way? Well, firstly, what I'm going to do is I'm going to say, well, I'm gonna set y equal to 4 to the x. But remember, it says in terms of e. How can I write this in terms of e? Well, all I can do simply is remember e to the ln's cancel out. So I could do e to the ln and I could just write 4 to the x, right? That is the same thing as 4 to the x, isn't it? Because the e and the ln will cancel. But what I can do here is in the power, I've got a log. I've got a power there. I can use my log laws to bring that power of x to the front of the ln, isn't it? So it becomes e to the x ln 4. And then now what I can do, just to tidy up a little bit more, I'm going to swap the ln 4 and the x, and you'll see why. So I'm going to put it like that and then put an x there. And the reason why I do this is because now you can see that this is just in the form of y is equal to e to the kx, where k is a constant, right? In this case, k is ln 4. And we know to differentiate this, this is just always equal to ke to the kx. So if I just follow that, then that would mean that dy dx here, the thing that we're trying to differentiate, is going to be ln 4 e to the ln 4 of x, right? Now, we're here. Remember what this is equal to. E to the ln of 4 is that, which is the same as 4 to the x, isn't it? These are the same thing. So now I can put it back. So I can say that I've got ln 4 times by just 4 to the x, which is just 4 to the x ln 4. So this is the way I expect you to do it in the paper, because it says in terms of E. I'll do it the other way because in an exam, I'm sure you'll be able to do both, but I just wanted to test this type of way. So by taking logarithms, how would you do it? So I'll do it underneath here. So again, I'm going to set y equal to 4 to the x. We're going to take the natural logs of both sides. So it's going to be ln y is equal to the ln of 4 to the x. And then what I'm going to do is I'm going to use my log rules to bring that x to the front. So it's ln y is equal to x ln 4. Now, remember what we're trying to do. We're trying to figure out what dy dx is, right? Now, this is implicit differentiation, isn't it? Because y is not in terms of x explicitly, right? It's ln y. So I need to differentiate this with respect to x. First, I do it with respect to y, which is going to be 1 over y. And then we're going to times by dy over dx. And then when I differentiate this, this is just x times ln 4. This is just the same as differentiating kx, isn't it? This will just go to k, right? When we differentiate a constant times x. So this will just be ln 4, wouldn't it? And then now dy dx, algebraically, we will just multiply by y. So dy over dx is going to equal y ln 4. But remember, y is equal to 4 to the x, isn't it? So therefore, you get dy over dx is equal to 4 to the x ln 4. So this is the way you would do it by taking logs of both sides. But I wanted to do it that way because it's my exam and I can do that. But yeah, that is part A finished. Okay, so part B says f of x is equal to 4 to the x over ln 4 minus x squared over 2 minus 4x. Given that y is equal to f of x as a turn up on x equals alpha, part B says we need to show that alpha is a solution of the equation x is equal to the ln of x plus 4 over ln 4 for 3 marks. Now, first thing that you should look at is this phrase here, turning point. Whenever you see turning point, whenever you see maximum point, whenever you see minimum point, whenever you see stationary point, these are all just synonyms for dy dx is equal to 0. In this case, f dash of x, isn't it? Because we're dealing in function notation. So what I will need to do is differentiate my function and set it equal to 0, and then use algebra to show that we get that equation. So f dash of x, what is that going to be equal to? So differentiating 4 to the x, remember we just did that in part A, that's 4 to the x ln 4. Now this division of ln 4 is a constant, so I still need to divide by the ln 4 as well. And then the next one, x squared differentiates to 2x, and I'm still dividing by the 2. And then minus 4x differentiates to minus 4, doesn't it? And then I'm setting this equal to 0. Now, tidying up a bit, ln 4s are going to cancel, 2s are going to cancel. It's going to be 4 to the x minus 4 is equal to 0. So we're here. We need to show that we get that equation. So firstly, x is the subject in this equation, isn't it? In the show that, right? So we have two options. We could either make this the subject or that one. How do you know which one to choose? Well, you've got a lens in your show that. The only way you could get a lens is if you were rearranging an exponential, wouldn't it? So we would need to make this one the subject, right? So that's what I'm going to do. So that means I'll naturally have to add on that to the right-hand side. So that will be 4 to the x is equal to x plus 4. And that's good because we've got x plus 4 there. Now take the logs of both sides, natural logs. It's going to be ln of 4 to the x is going to equal the ln of x plus 4. And then now we can use our log rules to say, well, the x will drop to the front. So I get x ln 4 is equal to ln of x plus 4. And then now we can just divide by ln 4. And then we get the result over ln 4. Perfect. And that is it. Fantastic. That's 3 marks. Now, part C is here. Let's read it. Let me just zoom in a bit. It says, using the iteration formula, xn plus 1 is equal to the ln of xn plus 4 over ln 4, with x1 equal to 0.5. Find the value of x3 to 3 decimal places. Okay, so again, this is just very, very straightforward. You're just going to put this into your calculator. We're going to store 0.5, and then you're just going to plug it into the formula, aren't you? So it's going to be ln of 0.5, but in this case, it's going to be answer because I've stored it, and this is what you want to do. And then you're going to divide this by ln 4. And this gives me x1, that's going to be 1.084. And then x3 would be this one, isn't it? And to 3 decimal places, that's going to be 1.173. So I'm going to say x3 is going to equal 1.173. And then now I need alpha, which is the actual root, isn't it? So what I'd want to do is I want to keep clicking equals because I want to see what it converges to. So if I keep clicking equals, it terminates there, isn't it? And it doesn't say to the degree of accuracy. And when that's the case, you put it to three significant figures, right? Which in this case is going to be two decimal places. So I'm going to say alpha is going to be 1.1. That's going to go up to a 9, isn't it? So it'll be 1.19 like that. So that's I and double I. Part D says the sketch in figure 1 on the next page shows part of the graphs of y equals ln of x plus 4 over ln 4 and y equals x and the positions of x1. On figure 1, draw a cobweb or staircase diagram to show how convergence takes place, indicating the positions of x2 and x3 on the x-axis. So I've got figure 1 here, right? Now we need to show how convergence takes place by drawing either a staircase or a cobweb. Now, whatever you're doing, whether you're doing a staircase or a cobweb, it's always the same thing. You start at your first value x1, you go up to your curve, and then you go to your line. So just think of it as curve and then line, curve and then line. So if I do that, I'm going to go up to my curve, which is going to be this one here. And then I've hit my curve. I'm going to go horizontally till I get to my line, right? And then this is going to be x2, isn't it? Right there. And then I go up to my curve again, and then I go up and I go horizontally to my line. So you can see that it's just going to be a staircase diagram. And in that case, this is going to be our x2, like that. And then x3 is going to be over there because we needed to indicate the positions of x2 and x3, didn't we? So that will be that. And then obviously this right here is going to be alpha, isn't it? So I'll put that there. Perfect. So that is part D finished. Okay, so part E says, in fact, f of x has two turning points, one at x equals alpha and another at x equals beta. By constructing an alternative iterative formula and using an appropriate starting value, show that beta is equal to minus 3.996 to 3 decimal places for 3 marks. Okay, now in an exam, you never, or I can't say never, I've never seen a question where they don't give you the iterative formula, but it's my exam, so I can do what I like. Anyways, the main thing is though, is remember, when you're doing these types of questions, locating roots, right? The way you rearrange your iterative formula will determine what roots you get if there are multiple in a function, right? So where did we first construct our initial iterative formula? It was in part B, wasn't it? Remember, this was part B over here. We had this equation f of x, we differentiated it set equal to 0, which was over here, right? And then we rearranged to make this x the subject. And this gave us, or this allowed us, I should say, to calculate the root at alpha, isn't it? Well, there's another root at beta, which the question says. So let's construct this a different way. Let's rearrange this a bit differently. How about we rearrange this x instead? Let's make this the subject of the formula instead and see what happens. So what I'm going to do is I'm going to write that formula or that equation there. So it was 4 to the x minus 4 is equal to 0. And now instead of rearranging to make this the subject, I'm going to make this the subject instead. So I'm going to add x on, aren't I? So it's going to be 4 to the x is going to, so 4 to the x take away 4 is going to equal x, right? And then in terms of an iterative formula, let me write it like this. Well, this would be n plus 1, and then this will be xn, isn't it? Right, so this is gonna be my alternative iterative formula, right? Now that's one part of it. We need to use an appropriate starting value. Now we're gonna use the root to help us find what that value would be. Now beta is minus 3.996, so it would make sense to use a starting value which is somewhere in that vicinity, wouldn't it? Right, so maybe I'm gonna say, for example, let's say x1 is equal to minus 4.5 and see what happens. So I'm going to say minus 4.5. I'm going to say equal. And then I'm going to put in there. So it's going to be 4 to the answer. Take away 4. And that gives me that. If I click and equals, we can see that we get that root, right? So we can just use that there. And then we can just say beta is going to equal minus 3.996. Now, that is not the only value you could have used, right? Remember, you're just going to try and use the root to help you figure it out, right? Or what value it could be. So I could have used, for example, let's say minus 1. Let's use minus 1 and see what happens. And then put that in 4 to the answer, take away 4. Like that. Click and equals, I get that root, right? So I could have used minus 1. Now, for example, if I use, for example, 2, let's see what happens here, right? 4 to the answer, take away 4. Okay, see, we don't get there. We get math error because it's just going to explode, isn't it? So you just basically want to use your root, or the root minus 3.996 to kind of guess what the starting value should be. And to be honest, once you get your alternative iterative formula, it's kind of like a trial and error process anyway. So yeah, hope that makes sense. Again, you probably wouldn't get this in the exam, but I just thought it would be good to do because it really if you got this right, it really shows that you really understand the topic of numerical methods and locating roots, and not even just this topic as well, but if you really want to access that A or that A star, you need to have a very good understanding of all of the topics. So it's not just about applying the formulas and stuff. You want to make sure you really understand what's going on, what they're asking you, and what the actual questions mean, and that way you'll be able to answer questions like this. But yeah, that's pretty much it. That's a part E, and that's the entire predicted paper finished. Hey guys, Daniel here. Hope you guys are doing well. So yeah, that's the entire paper. So I hope you guys found that helpful for your revision. Hopefully it wasn't too tricky. But yeah, I'm interested to hear your thoughts in the comments. I hope it stretched you and it's helped you. I hope it's helped you with your revision. Any topics that didn't come up in this paper, so for example, parametrics, recurrence relations, arithmetic sequences and series, logarithms, that will be in my paper too, which will be out in a couple of weeks from the upload date of this paper. And yeah, hope you guys keep studying hard. I've got a lot of stuff planned for you guys. I've got a lot of live streams coming up on TikTok and on YouTube. A lot of more walkthroughs, a lot of videos just to help you guys with your revision. So I'm really looking forward to it. And I've also got some Easter classes coming up as well. So if you're interested in that, I'll definitely put a link in the description so you guys can find more information about that. But yeah, all the documents will be on my website, so you'll be able to access the paper on my website, as well as any other resources, the past paper topic breakdown as well. I need to do the stats and mechanics one for that too, actually. But yeah, so again, hope you found it helpful. Again, really appreciate your support. If you found the video helpful, make sure to like, comment, and subscribe. And I'll see you on the next one. Until then, keep studying hard, and yeah, see you guys soon. Take care. Bye bye.